Hello, welcome to this video. In this video, I will talk about everything I think about basically. So, I've been working on this website for some time now, and on this website, I put everything I think about basically, and you can go to it, it's superintelligence.com. And so, in this video, I will go over the high-level overview, then over some more details, some more concrete things that I care about, and then like even more concrete. So, to start off with the biggest high-level overview, with the biggest compression, you could say, is that in general, I like to think about intelligence. Intelligence is very central to me, and it's very interesting to me, and I really want to know how it works. Then I like to think about all sorts of mathematics, then all sorts of sciences, then all sorts of engineering and technology, and mainly artificial intelligence in this context, and mainly machine learning as a subset of artificial intelligence. Then also I like to think about all the physics, and also learn and do and so on, and computer science as well, which is even more general than just AI. Then also some computational neuroscience, some cognitive science, which studies the brain basically, or that's more general, and then transhumanism, which is something I'm very strong in too. Then also, I think a lot about the artificial intelligence's benefits, risks, impact, and its future. So that's very important to me. After that, also, I explore a lot reverse engineering of AI, using, for example, mechanistic interpretability, which is one way of reverse engineering neural networks, the best way right now, I think, or deep learning and transformers. So then also, I like to explore different mathematical theories of artificial intelligence. That's also important to me. Then, more generally, I like to explore the future of humanity, of AI, of sentience, of futurology, of politics, how it will evolve, what's the current state, how can we think about it, and so on. Then, I like to think about different movements, such as effective accelerationism and effective altruism, which are very interesting to me, and there are much more movements I like to think about. And these movements, I think we can merge the ideas that they have together. So I will go later about the differences. I think both are nerds into AI, but in different ways, basically. For example, so after that, I like to think about longevity and like immortality and stuff like this. So how can we extend the lifespan, Then also how well-being works and how biology works. Also some philosophy and how consciousness works, because I don't think nobody really knows fully. Then different risks, not just risks from AI, but other types of risks, and different theories of everything. So this is one very general compression I like to think about. So I will add here that different movements. So yeah, this is like the most high-level compression of my brain. Now, some more concrete stuff is that I like to think about computer science, so which I already mentioned, and in there different language models, how language models work, because these are now the dominant AI paradigm that are the most popular right now. Which, AI field is much more than just language models, but they seem to be making a lot of progress recently, and I think that's fascinating. Then neurosymbolic AI, which is adding some symbolic methods, so not just statistical learning, but also like some, search and so on, which I think is important. Which it seems to be already happening with, for example, the new OpenAI's model, the O1, that's kind of it's fuzzy to say that, but they added sampling and search and so on and chain of thought. So it's not just pure deep learning, but it still is under the hood, you know. So yeah, so that's neurosymbolics. Then I like to think about generalization, how generalization works. I think generalization is a fascinating phenomenon. Then I like to think about artificial intelligence safety. And artificial general intelligence, how can we define it and so on, measure it and so on, and artificial superintelligence. So after that, I like to think about neurotechnology. So those were like AI related stuff. And in neurotechnology, like how could immortality work? How could we achieve it? And so on. I think that's very interesting. I wonder about the structure of experience and how could we manipulate it possibly? How can we formalize it and so on? Then different psychotechnologies, how agency works, how meaning works, motivation, how meditation works, how can we classify those, how psychedelics work. I think those are very interesting. Then in terms of like some more big picture stuff and long-term stuff and movements, I like to think about singularity, which, technological singularity, how that works. I will go into that later. Very, very accelerating technological progress. Then I like to think about long-termism. Actions right now matter in the long term. How can we maximize that? And rationalism, I think, is very interesting and important as well in today's age. Then some extropianism, which is a kind of philosophy, a techno-optimist philosophy. Then Teapot, which is this part of Twitter. I'm active there on Twitter, or X. I like to explore that community. Then hedonistic imperative is interesting to me. How can we abolish suffering in using biotechnology? But also, I'm about how can we augment intelligence. So, I will mention it here. Human intelligence amplification. That's something I care about a lot and think about a lot. How can we do that? Then cosmism, which is, populating the universe. Omnidisciplinarity and omniperspectivity. How can we use as many disciplines and as many perspectives, synthesize them, work with them all at once, use as many lenses as possible. I think that's useful and important. Then some more data science stuff. I like to think about how neural networks work, which is a subset of AI basically. Data science, then programming languages, software engineering. I'm interested into that as well. Some hardware engineering and electronics as well. Very interesting to me. Then I like to think about, so in another class of things, I like to think about metamodernism. So like that comes after postmodernism in our culture. I like to think about secular spirituality. How can we have like basically modernist spirituality, I guess you could say, but combine it in metamodern way with other ways. If you don't know these terms, we can go into that later. Or if you don't know any of those terms, you can just look them up on Google, on Perplexity and so on. I recommend Perplexity for everything. That's one AI search system. So, and how neurophenomenology works. Oops. Let me just quickly turn off something. So neurophenomenology, that's like hard problem of consciousness, for example. How can we solve that? Are there even solutions? Is it even solvable? Because I tend to be skeptical, to be honest. In some cultures it doesn't even exist, but whatever. Then metaphysics, how like what's the landscape there? like ontology, for example. That's very interesting to me. Then logic and ontology. Yeah. Then like how logic works. I think logic is very interesting to me. And also metamathematics. That's also very interesting to me. How can we like use mathematics to understand mathematics? So yeah, that as well. Then also some systems theory and information theory. That's like very interesting fields to me, like and algorithmic information theory, for example. And then I like to think about future, freedom, growth, flourishing, and politics. How can we achieve freedom, growth, and flourishing in the future using politics? So that's also, I think, important. And then, yeah, and the overall goal, I would say, is like spreading sentience full of intelligence and well-being across the whole universe, making our civilization ascend to higher Kardashev scale, which is a measure of like how civilizations are advanced, which I might go into later, or you can Google it again. So yeah, this was high-level overview, very high level. And another high-level overview would be here. So this was sorted by how interested I am in these fields, like from the top to the bottom. Maybe I would put logic and metamathematics more on top. Yeah, like... yeah, it's like, it changes. It's constantly changing, so sometimes I'm more interested in math, sometimes in physics, sometimes in intelligence, sometimes in AI, sometimes in neuroscience, sometimes in futurology and politics and philosophy and so on. So yeah. Now, if I would want, like, so this was like how much I'm interested. So that's kind of sorting. Now, if I would sort it by like from scratch, like how I think about things from scratch, then I would go in this sorting, which I want to put in my book, which isn't done yet. So far, it's just a table of contents, where basically everything starts with science. And inside science, you have social sciences, formal sciences, natural sciences. So in there, from formal/social sciences, you start with philosophy. Under everything is philosophy. Then subset of, if I simplify it, then subset of philosophy is mathematics. Then if I would and that's part of formal science. And if I would simplify that, then subset of mathematics is applied mathematics, like physics, which is part of natural science, when the patterns you model match the real world, the physical world. And then you have like biology, neuroscience, and in there you have like, and those are like emergent on top of physics. And in biology and neuroscience you have phenomena like intelligence. And how does that work? And you also have technology and artificial intelligence. So you also build technology like artificial intelligence. And how does that work? I'm curious about how to build it, how to maintain it, how to make it more intelligent and so on, which I will go into later. And then, like, you have large language models, neurosymbolic AI, and so on. You have the mechanistic interpretability, the reverse engineering, the mathematical theory of artificial intelligence, you can study it. Then you can compare artificial intelligences and biological intelligences, which I think is very interesting. Yeah. And then the AI's benefits, risks, impacts, and future. The future of humanity, AI sentience, futurology, and politics. The different movements. Immortality. How that works. And then surviving the end of the universe at the end. And then after that, you can go into some cognitive science, how consciousness works again, more philosophically, ontology, questions like, why is there something rather than nothing? That's like fascinating to me. More philosophy, more metamathematics, meditation, and everything. How you can think about everything. Like some people think about what is nothing, but I like to think about what is everything. How can we think about the concept of everything? Then like different theories of everything, which I think are very fascinating. And yeah, important. I will also add logic here. I think logic is important, and there are different types of logics, which is cool to study. And effective omni, which I'll talk about later. Yeah, which is my own like synthesis of all perspectives and everything, all scientific fields and so on. Yeah, so this is another like very general way how to think about my brain. I think it's very important and interesting. Artificial intelligence X biological intelligence. Yeah. So, now if we go more concretely into the different fields. So, I'm interested in artificial intelligence, fundamental research, and engineering. So, I ask questions such as like, how does artificial intelligence and intelligence more generally, that might soon become very general and super intelligent, works from an interdisciplinary lens using all sorts of mathematics and methodologies from computer science, statistics, information theory, physics, mechanistic interpretability, cognitive science, geometry, pure mathematics, and so on. And I think about like, what is the mathematical theory of intelligence using all these tools together? And I wonder, how can we mathematically and empirically understand current and future AI systems, why and how they work, and how to make them much more reliable, robust, steerable, creative, intelligent, safe, etc., across all levels of their development. So that's something I'm very interested in. And I wonder, what are the current state of the art results and methods in research and engineering in academia, industry, mainly around AI, such as mathematical results, empirical results, and tools like PyTorch or AI development interfaces. And I wonder, what will be the future developments in scaling, data, algorithms, architecture, hardware, different wrappers on top of foundational models, how agents will work, how multi-agent systems will work. And they are getting better and better. And I wonder what would be considered artificial general intelligence, how can we define it, how can we measure it, and so on. Same with intelligence. I wonder, how can we define and measure intelligence? And how much does artificial intelligence safety play a role? And I wonder, what is the intersection of artificial intelligence, biological intelligence, and collective intelligence? And I wonder, how can we create a theory of everything in intelligence, which would explain everything around intelligence, basically, and predict, most like that's like important, not just explain, but also predict. Yeah, so those are, this is the AI fundamental research and engineering that I'm very interested in. Then, to move on, the big picture of artificial intelligence. There, I wonder, like, what are the benefits, risks, impacts, and future of artificial intelligence? How will the current artificial intelligence revolution transform humanity technologically, economically, culturally, governmentally, I wonder. And I wonder how to make sure that AI benefits everyone, such as by automating mundane tasks like dishes and laundry, helping science like AlphaFold, helping physics like Ferminet, which I will go into later more if you don't know these, like AlphaFold and Ferminet. Yeah, AlphaFold is for biology. And how can it help with mathematics, like AlphaProof? I can mention that here. AlphaFold in biology. And also healthcare, like diagnosis. How can it help with diagnosis? And I wonder in technology development, how can it help? Like with recursive self-improvement. Where AI designs itself, basically, or other technologies, not just AI. Like, how can it design other technologies, basically? Like tools against pathogens, for example. And I wonder about AI in programming. Like, different people are trying different autonomous software engineers, not just copilots. But I think copilots are also like very cool, and I use them all the time, basically. So copilots and autonomous software engineers. And I also wonder how can we help make them like prevent various risks, like biorisk, for example. How can we like use AI for that? And how can we create useful chatbot assistants and robots that are grounded in reality, that are factually grounded in reality, etc. So all of those different use cases I think are like very useful. And I wonder, is artificial intelligence a tool like scissors? Or is it like internet? Or as powerful as nuclear weapons? Or something else? Like, people make different analogies about what kind of tool it is. Or are we breeding new species that will require rights, moral rights? Some people also think about it. Are we growing or breeding? Yeah. Are we growing new species that will require moral rights? And I wonder, how does existing technology already make us cyborgs? And I wonder, how can we collectively create optimistic stories about our future? Yeah. Yeah, so I wonder, how can we collectively create optimistic stories about our future and build that great future together? And will there be a post-scarcity economy where technology generates abundance for all, not just for a select few? How to make sure that people in AI and in general in the fourth industrial revolution with exponential automation don't suffer? And maybe something like universal basic income or services will be needed to catch up with job loss with increasing automation? And is universal basic income or services realistic? And how to minimize power concentration in the hands of the few? And how to prevent realistic risks? Is rogue superintelligent AI likely? And how to prevent regulatory capture? And is singularity near? And how will singularity look like? Those are the questions I ask myself daily and ponder on. Yeah. So, now if we move on to science, technology, engineering, mathematics, physics, biology. So, not as much AI anymore, and now let's move on to some like in general STEM. So like, yeah, this is what I just said. So I'm very curious And I often wonder, how does reality, science, technology, engineering, and mathematics work? How does structure of what is the structure of everything? What equations govern everything across all scales? So I think about that often. And what is the best, simplest, most predictive and explanatory, most useful, integrating, unifying model in all natural sciences, using all its applied mathematics methods like linear algebra, calculus, differential equations, geometry, topology, discrete mathematics, probability theory, statistics, graph theory, etc.? How can we use all these tools together to understand reality? What is the source code of our reality? Yeah. And how can we use the methods of physics in as many fields as possible? And how to effectively map all of knowledge and follow state-of-the-art in many fields at once? And how to most effectively create a generalist synthesis, but also narrowly model reality concretely on each level of abstraction, on all scales, scruting the seemingly inscrutable realities quantum fields with its emergent laws. How do we turn the seeming alchemy of empirical sciences into deep understanding of its underlying mechanism by the most optimal mathematical compression? And how can AI accelerate this process? How can we infer the best tools for different domains, for different use cases? How can we understand and unify all mathematical subfields using abstract mathematics such as category theory? How can we integrate together all methods from different physics subfields, such as tools from classical mechanics, statistical mechanics, quantum field theory, and so on? How to solve quantum gravity? Are string theory and loop quantum gravity good solutions to quantum gravity? How to create a theory of everything? And theory of everything in fundamental physics, unifying all the fundamental forces. In theory of everything in all of physics, combining it with the physics on other scales, not just the fundamental ones. And theory of everything in natural sciences. How can we emerge from physics to other fields, other scientific fields in natural sciences? And theory of everything in all of science. How can we combine it with formal sciences and social sciences and so on? So I wonder about that. So this was science, technology, engineering, mathematics, physics, and biology stuff. Now, if we move on to some technorealism, future of humanity, AI, sentience, futurology, and politics, I'm often wondering about how to not be naively techno-optimistic or techno-pessimistic when it comes to technology, but something in the middle, technorealistic. How can we gather the benefits of technology and minimize the risk of artificial intelligence and technology in general? And how can we merge the ideas of effective altruism and effective accelerationism? And how can we the most effectively use science, technology, and other methods to adapt or solve the biggest world problems and prevent risks from suffering, for example, poverty, wars, injustice, crises, existential risks such as nature, and how to prevent existential risks such as natural engineering pandemics, nuclear war, or environmental collapse. How is polycrisis actually real? And how do we solve it? Actually real, and how do we solve it? So, polycrisis is this interconnection of these different crises that they reinforce each other. And how to use AI and other technology to solve and prevent all these problems. And how to prevent technology itself becoming too powerful in the hands of the wrong people. like dictators, for example. Should it be open source? And what is the best political system? Is it liberalism, collectivism, individualism, global governance, benevolent dictators, AI-assisted governance, global AGI governance, decentralization, democracy, anarchism, minimal state, and so on? Should we regulate more or less? And should we regulate more or less, and regulate what? And when? And regulate what and when? Then I think about how do we collectively steer all of sentience, not into oppressive dystopia without democracy or complete extinction, or plateau without progress, but into collective protopia, collective growth of sentience and technology, of science and technology, intelligence. Of collective growth of science, technology, intelligence, well-being, connection, knowledge, drive, motivation, freedom, agency, survival, long-term adaptability, stability, sustainability, love, peace, safety, meaning, fulfillment, self-actualization. How do we get there, I wonder? So, this was Technorealism and Future of Humanity, AI, Sentience, Futurology and Politics. The next section that I care about a lot is the brain, mind, and body. So, I often ask myself, what is life? How does the brain work? How to integrate the lenses of biology, neuroscience, chemistry, computational neuroscience, statistics, probability theory, physics, machine learning, systems theory, or other mathematics in terms of understanding the brain. I think about how does learning work? What kind of intelligence is biological intelligence compared to artificial intelligence? What is the intersection between biological and artificial intelligence? How to reverse engineer and amplify human intelligence, agency, well-being, and longevity to catch up with exponentially increasing machine intelligence using neurotechnology, biotechnology, and other methods. How does well-being, agency, drive, productivity, meaning, etc. work on the level of the brain and the whole society according to cognitive science? On what level is it genetic, and on what level is it environmental? On what level are factors influencing these phenomena genetic? On what level are factors influencing this phenomenon genetic, and on what level are they environmental? What is the physical substrate of experience? How does experience arises? What's the best philosophy of mind position? What are the best psychotechnologies and neurotechnologies strengthening or transforming the neuroscience and software of the brain? For example, intelligence, well-being, and longevity. Like brain-computer interfaces, meditation, philosophy, psychotherapy, self-help, cultures, substances, cold exposure, or just healthy lifestyle. What are the realistic limits? How can we upgrade our sentient substrate collectively? How to achieve longevity? Is immortality a solvable engineering problem? I wonder. And how? Then I care about metamathematics and philosophy. So yeah, this was brain, mind, and body kind of stuff. And in mathematics and philosophy, I think about what is the most useful logic? and foundations of mathematics and metamathematics like set theory, homotopy type theory, or category theory? And what are the most beautiful, novel, and exotic parts of formal sciences? How can we mathematize ethics? What are the best positions in metaphysics and with ontology? What is the best epistemology? What is the best interpretation of quantum mechanics? How does identity work? What are the best positions in philosophy for science? What are the best positions in philosophy for science, meaning, well-being, and freedom? Is there something rather than nothing? How to create a theory of everything. In philosophy, in culture. So, how can we unify different philosophical, like continental and analytical philosophy and so on? How can we find bridges between different philosophical, like Western philosophy and Eastern philosophy and so on? How can we find bridges in culture? So like metamodernism with different emerging cultures. Metamodernism is this unifier, basically, you could say. And also the concept of meta theory of everything, where you take all these different theories of everything that people construct, either in physics or in philosophy and so on, and try to find a higher order logic, higher order maybe algebra or something. And you can go even beyond meta theory of everything and so on, recursively, because you're free to do whatever you want. Yeah, so that's fun. Yeah, it's more of a play, I think. Then I wander beyond polarization. So this was metamathematics and philosophy. So, and beyond polarization, I wonder, how can we collectively, effectively communicate and understand what is empirically true by stillmaning each other, accelerating omniperspectivity, bridging between each other, instead of polarizing tribalism more disconnected from reality, leading to improved collective decision-making? How can we understand our limited computational power of our brain? Of our brain. Limited data and perspective. When we consider ourselves information processing agents that model how can we understand our limited computational power of our brain, limited data and perspective, when we consider ourselves as information processing agents that model the world's enormous growing complexity together to collectively flourish in the future of humanity, AI, sentience, futurology, and politics, and the future of the universe? How can artificial intelligence help us in this process? So this was beyond polarization. Now I think about meditation, experience, meaning, art. So how does meditation and psychedelics work? What are the best, most optimal meditation techniques and actions in the real world for internal metaprogramming, cultivation of well-being, intelligence, connection, meaning, freedom, motivation, and drive? How can we make spiritual tradition scientific? How can we engineer the best psychedelic experience? How to use metamodernism, worldviews, philosophical assumptions, or identities to most effectively in different contexts? How to balance acceptance and change? How to be, do, and become the most meaningfully? How to solve the meaning crisis and loneliness crisis? And, or to be more precise, how real is the meaning crisis and loneliness crisis, and how to solve it? And what are the best possible experiences? What are all the possible experiences? Can we map out the state space of consciousness? What is on the edge of the mind? How do we approximate with language and model experiences that go absolutely beyond any conventional conceptual understanding when all mental faculties alter or dissolve? And I also love surreal, maximalist, psychedelic, mathematical, intellectual art full of complexity that induces awe. Yeah. So this was meditation, experience, meaning, and art. Then I wondered about the ultimate existential challenge. Like, how to beat the ultimate existential challenge, I wonder. The second law of thermodynamics. Like, how to survive the heat death of the universe, or however the universe will die. Doesn't have to be just the heat death. How to achieve resistance to entropy. How can we together achieve resistance to entropy? Optional transhumanistic merging with each other or machines or the universe and so on. For every being, using the most optimal collective, emergent, self-organized, sentient, coordinated, thermodynamic, cybernetic architecture. You can Google those words if you want. That might expand into the whole universe and become a beautiful cosmic constellation of linked post-humanist clusters of sentient matter of any form it wishes to shapeshift into, such as raw computronium. How? I don't know. Maybe it is possible to achieve full flexibility. Maybe not. Such that we can actually survive this Darwinian universe. Who knows? And the idea that I like is effective omni, which means steal men and, if possible, verify all models from all disciplines, all theoretical, applied, natural, formal, social sciences, all movements with worldviews shaping the future, all overall philosophical and other perspectives, and synthesize them on a higher level of complexity as compatibly as possible for collective survival, well-being, flourishing, growth of all of sentience, increasing intelligence, and ascending the Kardashev scale. Let's integrate it all into one useful framework. So, reduce suffering in the universe, increase prosperity in the universe, increase understanding in the universe. And the best way to do that is with AI and other technologies, such as from the fourth industrial revolution. So, I like the slogan, like super flourishing, super intelligence, super well-being, super longevity, super understanding, and super curiosity. All of them in the present and in the future. I'm for all of it. Yeah. So this was compression of my mind into one page. I also wonder, like, for example, in the safety of AI, I think what is interesting is, for example, also formal verification. Yeah. But I'm gonna go into that later. So, now let's delve deep into everything much more. Delve. You know, I've been talking with LLMs when I say delve. They really love delving. So, let's go from first principles. So, under everything is science. So, if we go to science, you can define science as rigorous, systematic endeavor that builds and organizes knowledge in the form of testable explanations and prediction about the world, allowing for controlled building systems with technology. I would say science is more general because because natural sciences, social sciences, and formal sciences all fall into this. So, under everything in science are formal sciences. And formal sciences is a branch of science studying disciplines concerned with abstract structures described by formal systems, which use a priori knowledge as opposed to empiricism. Yeah, so formal sciences, so stuff like mathematics, computer science, logic, systems theory, systems science, theoretical physics, information theory. Those are like under everything. And also metamathematics. So So if we want to build reality from scratch, we need some language. Formal science is basically this cauldron in which we grow new language, you could say. And the best knowledge, the best language that we have is mathematics. So, but in general, philosophy is on top of mathematics, basically. And it is technically language constrained by trying to explain something vaguely or strictly formally. Yeah, you can do vague philosophy, or you can try to be more formal, like in mathematics. So philosophy has also ethics, epistemology, logics, and metaphysics and ontology. We will go into that later. Now, in metaphysics, we will assume philosophical assumptions like physicalism, but we can also assume idealism or something else. Now we will just assume predictive realism, I call it, which is models have a degree of truthfulness on a spectrum depending on their predictive power with their certain accuracy and precision from various perspectives. Mathematics excels at that, and all other philosophy is just kind of, for me, like from my engineering brain, part of my brain is just instrumental cognitive glue around all sorts of different predictive models, and usually the predictive models are some sort of applied mathematics. So we're gonna work with this epistemology, with this ontology. But I think also that the nature of the universe is completely indescribable, and we have a bit of tools to slightly manipulate it. But the way how we can manipulate it with technology that derived from all those mathematics and empirical sciences is fascinating. So let's stick with that. So in mathematics, so if we take a branch of analytical philosophy, there's set theory and logic, so we will use classical logic or intuitionistic logic, whatever. Science uses both. But intuitionistic logic, where you don't have the law of excluded middle, so you cannot prove something by proving its opposite, is something that is useful because we can actually compute it, and you also don't do most of the time infinite computations. So something like a Shabak's epistemology and ontology, computationalism basically. So yeah, depends how broadly I define computationalism. Some people say infinities are okay. Let's not go into this rabbit hole. And that infinite hypercomputations are real. Let's not go there. Let's stay what we can work with actually in science. So, and use it to predict. So if we stay in there, then in mathematics, everything is mostly based on set theory. Some people work in category theory. Yeah, so as you can see, this is the landscape of mathematics, for example. I always link everything. If you wanna learn mathematics, here you go. MIT stands for go and learn it. Or whatever other. So in all pages for all sciences, I always link infinite resources. I always give definitions, main resources, and then I sometimes use AI to generate landscapes, and I think they are useful often. So yeah, as you can see in mathematics, you have very broadly, you have like set theory, and there are also different foundations of mathematics. So very broadly, you have that. I made a map I think in here. Yeah. This map is unfinished, but it broadly describes how I think about it. Maybe I could have shown this before. So yeah, at the top you have like philosophy with like ontology and metaphysics, blah blah blah. So we will stay with monist physicalism. Everything is made of physics, and it's one. In formal sciences, as you can see, mathematics, and in the foundations of mathematics, you can have set theory, which is using classical logic, or you can use the intuitistic logic, intuitistic type theory, or homotopy type theory, and you can use categories as your foundational objects, or you can use homotopy type theory as your foundational axiomatic system, or you can use Zimmer-Frank set theory, such that you don't have Russell's paradox. Yeah, because in classical set theory, you get into self-reference that breaks down everything. Yeah. And in there, you can build different pure mathematical fields. So as I described before, in mathematics, you have algebraic geometry you have like geometry, analysis, algebra, number theory, and discrete mathematics. And then there's also like probability theory. Yeah, there's also mathematical physics, which you can consider as pure math and not really math. Not really empirical sciences, but hopefully no string theorist that thinks the opposite is watching. I don't know. So yeah, and you can have like algebraic geometry, discrete, general topology, and so on. You can have like calculus in analysis, differential equations, and so on. You can have in number theory, and in discrete mathematics you can have like graph theory. So those are like different. And in metamathematics you can like do the category theory, madness, and homological algebra, etc., whatever. Yeah. So this is the language that we will use to describe the world. That I use, that science uses, that I like the most to describe the world. So there's like, yeah, you can see most of it here. Measure theory, dynamical systems. So yeah, and yeah, as I say here, mathematics, the purest language, the language of formal patterns, the language of generalization, the language of order, the language of unification, the language of deflation, the language of existence, the language in which the universe is written in, the language in which all the scales of reality operate in. I love it. I wish I could grasp all the mathematics of our reality, from the most fundamental to the most emergent, all at once in a single thought, beyond this limited brain trying to understand itself and predict the environment. Yeah. And math and physics is so magical, such that you have an explosion of so many equations, properties, theorems, etc., popping out of just a few axioms, definitions, and assumptions playing together, like in set theory, linear algebra, calculus, algebra, probability, and in physics, conservation law, symmetries, Newton's equation, Turing equation, in statistical mechanics, and so on. Yeah. So I really love this language. And so if we come out of mathematics to empirical sciences, so if we go from science to natural sciences, yeah, natural sciences, basically, they describe the world. Functions describe the world. That's a reference I just thought. You can Google functions describe the world. That's one professor was very, very big about that. And the main one is physics. I think the physics is the best field for this. So maybe I can describe it here. Yeah, in physics, like you have classical mechanics, relativity, quantum mechanics, statistical mechanics, quantum field theory, dynamical systems theory, information theory, standard model of particle physics, and the different like string theories, quantum gravity, and so on. Yeah, and in natural sciences in general, you also have chemistry, biology, neuroscience, psychology, system science, systems theory, and different multidisciplinary, like cognitive science just combines AI, neuroscience, consciousness, linguistics. Yeah. And then there's also applied mathematics. Yeah, a subset of mathematics that you can use to apply to the real world. So, we can build structure of reality from first principles here. That under everything you have quantum fields, as described by the standard model of particle physics. So the standard model of particle physics is relativistic quantum field theory. So, and it uses like so many maths, like it uses like group theory, differential geometry, linear algebra, calculus. You can use topology. You can approximate stuff with perturbation theory, and other numerical methods. With functional analysis are used in quantum mechanics as well. Lots and lots of different mathematics are used. So if you want to learn physics, again, I linked lots of resources. Leonard Susskind's theoretical minimum course, and it's like good. Or you can use the geometry of physics and lab if you want to do it the hardest way possible, which is in the language of category theory instead of set theory, and your mind will blow up from infinity sheaves, infinite toposes. But I want to understand that eventually, but I just don't have now, didn't put enough time in it. There's more resources. MIT has resources on everything. Classical mechanics, quantum physics, relativistic quantum field theory, and so on. Physical chemistry, black holes, etc. Non-equilibrium, statistical mechanics. So the standard model of particle physics uses stuff from general relativity, uses from quantum physics. Well, not really, just special relativity, because I will mention here that we still haven't the standard model describes 3 of the 4 fundamental forces, like the strong, nuclear, weak, nuclear, and electromagnetic. It does not include gravity, and the reconciliation of quantum mechanics with gravity remains an active area of research in theoretical physics. So, so standard model is, so the quantum fields in the standard model are fundamental to our understanding of reality, and while some other theories like string theory or loop quantum gravity propose more fundamental structures such as strings or loops, spin foam, these remain speculative or unproven. I like to joke around string theory, where string theories be like, just one more dimension will fix the theory. So it will have empirical evidence. Whatever. But it's great mathematics. It's like euphoric mathematics that I want to learn because, it's like, I love all mathematics. And loop quantum gravity had some issues recently. I think I linked it in here. Some observation that was like, brr. If you want to learn loop quantum gravity, here's Carlo Rovelli, great resource. So this might be actually learning the most. I think standard model right now is the best, actually. Still, well, it is. It's like, it is the quantum electrodynamics are a big part of that describe the electromagnetism and electrons. So, the most accurate model we have of reality right now. The closest we are to the source code of reality, to the fundamental structure of reality. But it's not the only patterns that exist. There's all the emerging patterns. So, here, the behavior of quantum systems is generally described by quantum mechanics, with the Schrödinger equation being fundamental for non-relativistic systems. In quantum field theory, relativistic equations such as the Klein-Gordon or Dirac equations are used. These fields exist within spacetime, and the curvature of spacetime due to matter and energy is described by ancient theory of general relativity, with this curvature manifesting as gravity. So, particles exhibit quantum properties such as quantum superposition and quantum entanglement, and as systems become more complex through the composition of these particles, systems of particles and systems of systems. They can display varying degrees of quantum or classical behavior. When these systems interact with their environment, they undergo decoherence, and quantum Darwinism describes that. So quantum, yeah. Best described by quantum Darwinism. Yeah. Quantum Darwinism describes how through using the process of decoherence, how the classical world emerges from the quantum. Or I still have yet to grok all the details, because that seems to be the ultimate glue of the fundamental quantum and the classical at the top, which tends to make them appear more classical. And generally, more complex systems that interact strongly with their environment tend to exhibit more classical behavior. So at larger scales, yeah, and like quantum computers, are cooled such that the quantum effects are maintained. Yeah, so quantum computers are like very good at that. And we're still like making it better and better and better. So at larger scales, more complex systems give rise to emergent phenomena described by higher level laws. These include various branches of physics, as well as chemistry, biology, ecology, sociology, astrophysics, and other natural sciences. While these emergent laws are ultimately based on the fundamental laws of physics, they often provide more practical descriptions of phenomena at their respective scales. And the standard model describes three generations of matter particles, quarks and leptons. The 6 types of quarks are up, down, charm, strange, top, and bottom. The 6 leptons are electron, mu, tau, along with their corresponding neutrinos. Electron neutrino, mu neutrino, and the tau neutrino. Additionally, the model includes force carrying particles, photons for the electromagnetic force, gluons for the strong nuclear force, V and Z bosons for the weak nuclear force. The Higgs boson, discovered in 2012, completes the standard model, which explains how other particles acquire mass through interaction with the Higgs field. Yeah, so while the standard model successfully describes 3 or 4 of the fundamental forces, strong nuclear, weak nuclear, and electromagnetic, it does not include gravity, and the reconciliation of quantum mechanics with gravity remains still the area of active research, as I mentioned. Yeah. And you can like go into the maths of this all, the mathematical formulation of quantum mechanics. Yeah, Susskind has a good course on it. Yeah, so here you can like see all the different elementary particles and so on. It's beautiful. Gauge quantum field theory. Yeah. So that's the source code of our maybe simulation, which hasn't been fully corrected. And in terms of like information processing in this whole world, it seems like when Big Bang happened, there was not really like, there was like non-living matter and like self-organizing particles, and then like after some time like some non-biological, yeah, and there was like atomic and chemical synthesis, non-biological one, for like billions of years. And then like for millions of years there was first life-like stuff emerged, so like organic molecules, and then RNA and DNA, and in the chemical soup, so source of life is still a mystery. And natural sciences introduced new behavior by selecting those that's the survival of the stabilists, I would say, more generally. like universal Darwinism generalized. And then eventually like Cerebrum emerged in the different organisms, which using evolution just kind of brute forced, and very basic learning happened. So like, you know, organisms that do the same stuff all day or all the time, and don't learn much new stuff really, which is hard coded on the circuit level so much, not really plastic. So that's like the third epoch, you could say, in the evolution of information processing. Then like humans and other, then like neocortex emerged from hours to week. You can like master new complex skills, so you can learn so much new behavior because it's very like plastic, hierarchical, and you can learn much more. And now like digital neural nets are like learning even faster basically, and even more everything, slightly differently. Like, yeah, we will mention that later. And eventually like brain computer interfaces will help us like do learning in the brain almost instantly, learning in the neural nets also maybe almost instantly eventually, when we optimize it to infinity, whatever. And eventually like computeronium is a concept where you can like continually reconfigure cognition towards the limits of what the laws of physics allow. So like you could and learn all the fundamental physics, for example, with just a snap. So this is from Kurzweil Singularity is Neither book. So first like biology emerged, and now like more stuff is emerging in the future. Yeah, there's like more high level laws. So if we describe fundamental particles governed by standard model and add gravity, which is still unsolved, that together compose to give rise to equations of classical and statistical physics on high levels, along with systems theory, equations, information theory, and computation theory. So these interacting quantum fields with their fundamental particles in complex enough dynamics give rise to emerging equations of chemistry, which in turn compose to form biology, neuroscience, and social systems. And we use many of those laws to engineer computers like artificial intelligence and other technologies, which have various mathematical similarities. Like you can describe both by linear algebra, for example. And yeah, we will mention that later. This allows to various types of compatibilities between biological and artificial systems that already enable us to better understand and engineer AI and upgrade ourselves with neurotechnology. And this process will likely continue. And then you have laws like planets, galaxies, and the whole universe operate under many approximately deterministic laws, like astrophysics studies. And we can predict fundamental particles' behavior as well, but they are inherent probabilistic nature in the quantum wave function, and many of the digital computers are also like, yeah, you have like quantum mechanics for quantum computers, you have like electromagnetism for classical computers, computational theory for classical computers, and now like with some linear algebra, convex theory and optimization theory and so on, and some stuff from neuroscience and so on, you have this whole AI field basically, which is combining all of this together. Yeah, so since many non-trivial systems cannot be solved analytically, we have to approximate them with numerical methods. Chemistry and biology adds numerous approximating equations because we cannot grasp all the variables in play for many cases, but we can simulate femtoseconds to picoseconds of simple chemical reactions using quantum mechanics on classical supercomputers and quantum computers in chemical physics. And societal complexity is very intractable, but we can apply some very general laws from physics, statistics, game theory, evolution, game theory, fluid dynamics, thermodynamics, network theory, and so on. And the more macroscopic we go, the less fundamental quantum probabilities and fluctuation matter, as they tend to average out, and we get more deterministic behavior with some higher order dynamical complex systems made of subsystems, and so on and so on. Yeah. And yeah, different architectures emerge, and complexity grows as we go up to the levels with further tractable, somewhat deterministic dynamics of planets, galaxies, and cosmology. And we still have to discover and develop many better or new concepts, laws, frameworks, and technologies in all these fields and levels of analysis. The cosmological story of our universe, including why and how there is something rather than nothing, remains a mystery beyond our limited modeling, approximating and compressing perspective given our current data, time, and computational power. In its fullness, it's beyond our current comprehension. Yeah. I will quickly put a note, because I want to put an image of history of the universe here. Because, you go from Big Bang, then like planets emerged, galaxies emerged, life emerged, and so on. So I want to put that in, have that in the image. History of universe and standard model Lagrangian and standard model particle stable. Yeah, the standard model particle stables I showed. So, and I want to, yeah, I can show you the standard model Lagrangian. I have it in here. Yeah. So here's the standard model. It's kind of broken. I think it might be better in its glory, in its fullness, in here. Yeah. Beautiful. So this is the full expanded version, and this is just the kinetic energies and self-interactions with God's bosons, kinetic energies with electroweak interactions of fermions, Higgs masses and couplings, interactions between quarks and gluons, fermion masses and couplings of Higgs. So beautiful and lovely source code. So, this was physics, I guess. And for AI, I'm very interested that the capability that I'm most interested in, that if you give the system all of classical mechanics, if it could derive general relativity, quantum mechanics, out of it. Humans could do it. And all the empirical data, you would also give it. Give it all the most of known empirical data from the experience before the phase shift and derive it from there. So, yeah. And there's one like fun thought that solving quantum gravity might reveal a glitch in the fabric of space-time and fundamental particles and forces or strings or whatever is on the roll that allows for arbitrary code execution to exploit, to edit, or spawn arbitrary structures and laws. Not sure about it. I'm just thinking, yeah. So that was physics. Standard model, loop quantum gravity. It uses loops. Natural science. Yeah, so in formal science we have mathematics, and natural science we have that. We have biology and neuroscience. So neuroscience now, that's very important. So as we emerge from the bottom, as we emerge from we have fundamental particles. They somehow compose. I think I mentioned it in natural science. Yeah. Whatever. I can mention that later. That you have like fundamental particles. They have some equations governing them. Then they self-organize into different like chemical elements, the periodic table of elements. Then those periodic table of elements somehow self-organized into different molecules. I don't know, like glucose, for example. That's like very high level. Or like the different amino acids. Everything that makes out of our body. All of that somehow, like, you have protein. Then you have proteins in biology, which are made of amino acids. Did I say amino acids before? If I said aminokyselina, I meant amino acids, and I said it in Czech maybe. And these amino acids, like, and these amino acids together then compose into proteins and other like biomolecules, and other biomolecules are like with different compositions, like different elements. And then you have cells, which all the cells in the body basically learn, and then like you have neurons, which are more specialized for learning. As I said, there's cerebellum, which is more for like skills which are very very concrete and non-flexible. And in the neocortex, you have like more flexible hierarchical planning, and so on. So yeah, so we can study that using cognitive science, systems neuroscience, computational neuroscience, studies the information processing. You can like map everything about the cell. You can visualize all the microtubules, whatever, around the cells, etc. And in computational neuroscience, also a bunch of lectures that you can check out. There's like everything. And yeah, so like you have like you can study the brain using electromagnetism. You can study it using neural networks, as in like you can use the spiking neural networks and so on. So, and the brain seems to use a lot of other stuff. I think I mentioned it here. Is that, yeah, like, and at the same time, like, so the brain is basically all of this self-organized dynamical system, open dynamical systems that we take food and somehow convert it to papers or whatever, convert it to thoughts, convert it to words and so on. While AI is like, we took electromagnetism, we took silicon, while we are carbon based. So in that we use silicon. Well, there is also quantum machine learning on quantum computers, or like people are trying thermodynamic stuff. Thermodynamic computers, which is also like there are different types of like quantum computing, thermodynamic AI, whatever, and other like different paradigms people try. So so the brain seems to be different but same in many ways. Like the representations that the brain learn, you can use neural networks to see. You can use, like, I think this is where is it? Yeah, this, for example. Like, if you can approximate the dynamics of biological neurons, as this guy says, using like 6 layers, or him doesn't say it. That like neurons are like complicated. You can model using the Huxley model, which is like using electronics, and you can like, if you put in the NMDA channel, that adds in more nonlinearities. So you need 7 layers to calculate those nonlinearities. So like in this way, brain is different. You could say the information processing there. So yeah, the mainstream AI uses artificial neural networks, which use like linear algebra, statistics, optimization theory, basically just putting together very simple equations technically. Okay, yeah, like if you go to mathematical theory of artificial intelligence, there's a lot of stuff I will go into, but like in a simple way, you can see it's like just linear algebra basically. If you've ever done like neural networks, it's like gradient descent on top of like bunch of layers, which just do this. There's a bias. Yeah. So yeah, here's a neuron basically. Like very simple compared to lots of other maths in different fields. So yeah, Yeah, but you need partial differential equations if you want to understand the theory. But I've seen it so many times that it's simple to me now. Okay, so yeah, like AI uses artificial neural networks, while we are something closer to spiky neural networks. AI uses big propagation, while we are something closer to forward algorithm and using Hebbian learning. Mainstream AI is simple linear algebra, while Hatchley-Haskell models with non-linearities. Mainstream AI are static programs, while like we are like self-regulating, self-organizing dynamic systems like neurocellular automata is closer. Is the brain doing predictive coding? Is brain Bayesian and doing active inference? So that's like another model which people are also trying to use for AI. The Fristonian camp. Is the brain electromagnetism relevant? Some people think that the topology of that is relevant for computing. Are oscillations relevant? Neural oscillations are studied. And the complexity of biological cells is beyond comprehension. Like, all the from fundamental particles to chemistry, lots of complex chemistry, while the digital computers are very, it's not like random chemistry, it's still chemistry, like material science is a lot of chemistry, of course, but it's still, it's not as complicated as this complex system. This is more controlled, less adaptable. We kind of made, we steered nature, governed nature, and we reverse engineered nature such that we can control it. And now we have this computer which can run different linear algebra to calculate different AI stuff, right? So that's wow. Well, we cannot do that on this computer. That's we can measure thoughts to some extent using statistics, train neural networks. There's Brain GPT, for example, from, I'm not sure if that was from Meta or from China or something. We can decode the visual cortex. We are able, slightly, not fully, find a bit the representations a bit, and being able to use machine learning to correlate what someone is looking at, what is thinking, in what is actually thinking, having some accuracy there a bit when it's trained on him and so on. Then there's Neuralink, which is also reading, and people can now there's electromagnetic, there's stimulation, TMC, transcranial magnetic stimulation. So we can kind of work with this, we have different substances that we can use, different neurotechnologies, psychotechnologies, etc. That we can use CRISPR to edit the genes and so on. So we can do a lot of here, but we can also do a lot of here. We have this system based on silicon, on von Neumann architecture, on using electromagnetism. Well, in electronics you abstract away electromagnetism, so you don't use quantum electrodynamics in electronics. You use stuff like the Ohm's law, and Kirchhoff's law in electronics. And different architecture. You can, how you can look into operating systems theory, into hardware engineering, computer engineering, and so on. So that's different mathematics here, different mathematics there. What is conscious? Which kind of mathematics is conscious? Nobody knows. I think it's hard to tell. I don't believe there's a good model of testing for consciousness. There's different brain regions that correlate with consciousness. So or you can go Penrose and Hameroff, are they fringe or are they actually right? Is his Galilean quantum gravity microtubules collapsing the wave function madness, right? Maybe Penrose is right and we need quantum gravity supercomputer for AGI. Which I don't think we need. I think those hardware, what matters is the software, and this is too much hardware. Maybe not. Maybe this is an accelerator, and maybe we need the electromagnetic, because the big data centers that we use for AI, they are tons and tons of clusters of GPUs, and in technology you have quantum computing, thermodynamic computing, quantum machine, whatever. You have classical digital computing, and like, you have CPU, but if you train models on CPU, it takes ages. But you have GPUs, which are like specialized accelerators using linear algebra operations that you can use to on a hardware level to train. Then there are people trying to embed transformers into their own literally into hardware, such that it's even like many times faster than people trying to use the randomness of thermodynamics or quantum mechanics, whatever, to use it as part of randomness in equations, like in diffusion models, whatever. So people are trying to use all these different accelerators to optimize you can do memory optimization inside the GPU, inside the CPU, and so on. So people are also trying to that, or you can use like quantize. You don't have to use floats, which are big. You can use like 2 bits, 1 bit, whatever. So a few bits, much less bits, basically. So numbers. So that's something. All the optimizations you cannot really optimize here. You can optimize here maybe mentally, but future neurotechnologies, increasing IQ, increasing well-being, increasing longevity, I think will be able. Like right now, we can already use like nootropics. Probably not sure to what extent increases IQ. Like, if we go to augment human intelligence amplification, like, yeah, you can like use nootropics, psychedelics, whatever. You can use like all these different digital magnetic stimulations, neurofeedback, neurotechnology, genetic engineering, meditations, etc., stress reduction techniques. Computer doesn't have to do this to be able to like be more efficient. You just have to. The hardware is so strict. While this is so fluid, adaptable, just constantly changing plastic. Yeah, you can like cognitive offloading, which I'm doing right now. This whole exocortex. Basically. Yeah, Wikipedia's. You can use collective intelligence. Like Wikipedia's are collective intelligences. Personalized learning, accelerated learning, you can be constantly stimulated and so on, have like better influence from, yeah, also like nutrition and so on is important. Yeah, in the future, like AI human merging and stuff like this. So yeah, I think intelligence amplification will be big and is already big. So that's like neuroscience, I would say. You can study it on all those levels. I maybe went too much of the on tangents, but why not? Okay, so we talked about like what AI uses, what algorithms, neural networks, deep learning is just a subset. So I will first go over what exists more here. That you have like lots of different, you can, if you want to learn AI, I recommend Stanford, everything from Stanford, neural networks, 0 to hero. And I'm not sure if I showed in physics, but before we go to intelligent, yeah, you can just learn all the physics here. I recommend it. Yeah, be right back in a second. Yeah. So I'm gonna mention here that what I think about a lot in artificial intelligence. is that what other paradigms than deep learning exist, such as neurosymbolic AI, self-organizing AI, neurosymbolic AI, self-organizing AI, Bayesian AI, self-organizing AI, whatever, evolutionary, such as symbolic AI. Etc. exist, and how good are they for different use cases? Yeah, so I wonder what other paradigms than deep learning exist, such as symbolic AI, neurosymbolic AI, Bayesian AI, self-organizing AI, evolutionary AI, etc. And how good are they for different use cases? How can we merge different paradigms? Yeah. So if we go to different paradigms, there are like different. So if we go to artificial intelligence and look there, we can define it as a system that is intelligent and constructed by human. Yeah, I will go to definitions of what it means to be intelligent, because that's something I've been in such a rabbit hole because people don't agree what is the reasoning, what is intelligent, and so on. Intelligence exhibited by machines, and the goalposts always move all the time. The new GPT-4o model got released, and the goalposts shall keep moving until the Cartesian scale improves, which is funny. Nothing ever happens. Yeah, you can learn it in here from Stanford and so on. So, applications, LLM, yeah, so there's symbolic artificial intelligence, machine learning, hybrid artificial intelligence. There's like different hardware for quantum machine learning, thermodynamic AI, large language model, scaling hypothesis. You can sort it by scale. There's like narrow intelligence and general intelligence. Then there's superintelligence, which I can define later, which I will define later. And there's like different search, optimizations, algorithms. There's logic, which is symbolic AI. There's neuromorphic AI, which I can mention in here. Neuromorphic AI. There's cognitive architectures, multi-agent systems. Yeah, there's like planning and different use cases, social intelligence, etc., etc. And yeah, and data science, statistics, explainable artificial intelligence, and so on. So under the hood, it's like tons of statistics, tons of data science, lots and lots of empiricism. So because deep learning isn't, lots of deep learning is like, you have the different like normalizations, the different like, oh, if you put normalization here instead of here, it performs better. So like, or like different, like you can like severe initialization, you can derive that mathematically, but it's pretty rare. Lots of the stuff in machine learning is like, oh, it worked empirically, I will just try it, and it works better than before. So it's like this empirical alchemy, basically, and that's like not good for steerability. But it uses like lots of simple maths, or like, some other. If we go to all the maths that can be used in AI, we mentioned it here. Mathematical, I do mention it here in theory. Yeah. So like, yeah, statistical learning also uses functional analysis. Then like you have deep learning theory, which uses all the good stuff like probability theory, calculus, differential equations, information theory, optimization theory. You have physics from statistical mechanics. Some people are trying to apply like we mentioned it there, quantum field. No, I don't. Some people are trying to apply quantum field theory. If you Google that, some people try to do that. Quantum field theory on deep learning. Not sure they found some. Not sure they find some practical results. Yeah, geometry deep learning is like, oh shit, all of deep learning is just symmetries. And categorical deep learning, yeah, so it uses group theory, differential geometry, topology, harmonic analysis, functional analysis, category theory, algebra, graph theory, geometry, computation, spline theory. That's like another model. Categorical deep learning that tries to understand theoretical deep learning, and it's like, if I understood it concrete, like I haven't dig deep into the paper yet, just like the introductions, and there are like, I think there are like symmetries, actually. Group theory, actually groups are too concrete, not general enough, so we will generalize groups to like morphisms in categories, and that's actually better, and you can describe more structures. I'm like, ooh, interesting, okay. So I wonder about that. Single learning theory, yeah, that uses some statistical mechanics, algebraic geometry, and yeah, I was at a lecture on this, and that was pretty cool. Like they derived some generalization coefficient, if I remember correctly. Yeah. And it seems like deep learning generalizes is good because of flat local minima is like more sharp. Yeah, that sharp minima tend to generalize poorly compared to the flat counterparts in the like loss landscape, when you map out the loss landscape. And the gradient descent is more likely to run into flat minima during optimization. But some people say that sharp minima also generalize, but there are some sharp minima that generalize, but most apparently are flat, or something like that. Yeah. Yeah, and some other math. Yeah, and there's physics-based informing, and some people trying to connect differential equations. Yeah, lots of stuff. So that's like all the maths, and yeah, lots of statistics, whatever, and some other magic math. So, what even is intelligence? Let's come to that, I guess, maybe now. So we're talking about biological intelligence, we're talking about intelligence of artificial intelligence, then there's also like collective intelligence, where people are like, oh shit, for example, LLMs, when, they are trained on our reasoning patterns, on our facts that we learned and put on the internet, so they are like basically collective, and when we are like in this dialogue together, then we are like together co-creating a result. Basically, you could say, well, the new model is more thinking, so it's more autonomous on this spectrum, but they are not fully autonomous yet. So, etc. So, if we look at intelligence, which, you have like all these different types of intelligences that I just mentioned. I like the idea of omni-intelligent, that like combines all the different types of intelligences. Yeah. Comparisons, etc. Yeah, theory of everything intelligent would be able to accurately predict, given a physical, intelligent information processing dynamical system, natural or artificial, its hardwired or fluid architecture, its training data in its given modalities, its agenting access to given actions, what patterns does it learn. It would like be able to predict all of that, what capabilities emerge. It will be able to predict all capabilities according to like the input. Like, here's the input, the initial conditions, this is the capabilities the system will have. Emergently. Would be neat. Maybe chaos theory or something just breaks it and we cannot do that. But whatever. So, what is intelligence? There are like so many different definitions of intelligence. And I tried to map as much as I could here. In here. So some people say it's what the IQ tests, like in humans, it's like what the IQ tests measure. Not just in humans, like now they gave the Mensa IQ test to the GPT-01, the new GPT-01 model, and it was like from the previous models were like, I think 90, and the new model is like 220, which is like, what? Okay, so maybe that says something about IQ tests, or I don't know what it means, like how, whatever, how you want to interpret it. So there's like different ways to measure intelligence. You could like do it, I can mention it here because fire intelligence, so many intelligences. You can there are different types of definitions. There are like cognitivist definitions and behavioral definitions. Treating the system as a black box, and measuring its behavior. And cognitivist, which is like looking for mathematical or not patterns inside the system instead of its behavior while it's performing tasks. Its behavior and how it's performing tasks from the outside. So there are different classes of definitions. So there are different classes of definitions. Behavior definitions are treating the system as a black box, and measuring its behavior and how it's performing the tasks from the outside. And cognitivist definitions, which are looking for mathematical patterns inside the system while it's performing tasks. So defining, looking for, and measuring mathematical patterns inside the system while it's performing the tasks. So like some people are like, you have to do this symbolic process in order to be intelligent. Some people are like, you just have to pass the Turing test to be intelligent or something. Which I mentioned in the AGI definitions. This is just intelligence definitions. So the IQ test is definitely behavior. Intelligence is compression. Technically, you can say that's cognitivist. So that's like another one type of definition. Then there's like intelligence is a collection of task-specific skills. So how many tasks you can do specific. So you can like relatively static abilities or programs that you can collectively like implement. So like if you overfit the whole world, basically, you don't have to generalize out of distribution in this definition. You just have to overfit the whole world. And that will make you like, here you go. Where intelligence is viewed as a collection of vertical, relatively static programs that collectively implement intelligence. Like, yeah, and you can say it's like doing this task, so that's like the cerebrum, basically. It's like being able to do that task, as long, and if you take the space of all possible tasks that are needed to survive in this world, and you don't have to come up with new stuff. Then there's like another type, classes of definitions, which are like intelligence as a general learning ability, which sees intelligence as acquire new skills through learning. That could be directed to a wide range of previously unknown problems. So Chulet likes to define this as the measure of, so the intelligence of a system is a measure of its skill acquisition efficiency over a scope of tasks with respect to priors, experience, and generalization difficulty. Or in other ways, intelligence is the rate at which a learner turns its experience and priors into new skills at valuable tasks that involve uncertainty and adaptation. So, and he also put it into algorithmic information theory definition in this paper on the measure of intelligence. So I like that. Formal definitions of intelligence, great. We can actually work with that. Yeah, so that's like general learning ability view of intelligence, basically. To learn task-specific skills. Yeah, in the general learning ability paradigm, you see the mind as a flexible, adaptable, highly general process that turns experience into behavior, knowledge, and skills. And those two, like collection of task-specific skills definition and general learning ability class of definitions, are saying that that are like mapping to the theory of fluid and crystallized intelligence, where, yeah, crystallized is the task you learn, and fluid is the inherent generalizing capability, you could say. And also it maps to opposing views in cognitive science, that one views the mind as a relatively static assembly of special purpose mechanisms developed by evolution, only capable of learning what is programmed to acquire, and another set, another lens in cognitive science views intelligence and the mind as a general purpose blank slate capable of turning arbitrary experience into knowledge and skills, and that could be directed at any problem. So, yeah, those are like the different definitions of intelligence. So then there's and then there's like, I collected as many as I could. So like Legenhatter says, intelligence measures agents' ability to achieve goals in a wide range of environments. Minsky is like, AI is the science of making machines capable of performing tasks that require intelligence if done by humans. That's kind of, yeah. If we go to like Carl Friston's video, I recommend this video of like, they go over different definitions of intelligence on Machine Learning Street Talk in here.
Hello everyone, I'm here to talk.
It's very cool stuff. So in here, they see Carl Friston's view is that intelligence is the capability to accumulate evidence for a generative level of one sense world, also known as self-evidencing. Yeah, again, Shane, like, ability of an agent to solve varied tasks in different environments. Again, Cholet efficiently creating generalizing abstractions from limited prior experience. Peng Wai is the adaptation efficiency. A general characterization is of intelligence is, so some other definitions is the ability to plan, imagine scenarios, and have narratives that play out internally, some counterfactual reasoning maybe and stuff like this, and selecting actions and policies and committing to a course of actions. Information theoretic view is like belief updating at different timescales. Physics-based definition is that emerges from systems that minimize free energy and maximize model evidence. Yeah. In thermodynamic definitions, it's like maximizing dissipation. The more you dissipate, the more intelligent you tend to be. I don't know. Jeremy England has a model of life using thermodynamics. You can use that for intelligence, probably. Curiosity-driven view, intelligence involves the actively seeking out information to reduce uncertainty about the world. Activist is like, no, you have to have embodiment and active engagement with the environment in the cybernetic thought, action, measure loop. hierarchical view that says that you also need to create and manipulate abstractions on various levels of complexity, at various levels of scales. Social construct is like intelligence can be seen as the ability to infer and adapt to social norms and expectations, and predictive processing view is like intelligence is the ability to minimize prediction errors about the world and oneself, which is my ontology basically. This is and use general models for that, compress. Yeah, so like you can unify all of this into, and there's much more definitions, which are similar. So like intelligence is thermodynamics. Yeah, that's also possible. Ability to learn, understand, apply knowledge, acquire, adapt, achieving complex goals in complex environments, use optimally limited resources, including time to achieve goals. So yeah, this was Ray Kurzweil, the before was Ben Gold, so ability to solve hard problems, yeah. Pei Wang is a lot about the adaptability. So yeah, that's like different definitions. I'm like, do I mention it here? Yeah, like my current favorite is the ability to generalize, to mind previous experiences, to make sense of novel situations. Like, yeah, the main crux is like that people battle on. Is intelligence collection of special purpose programs or a general purpose blank slate that can be filled with any computations or combinations of both, something in the middle or something else? I would say, yeah, and I would say like something like omni-intelligence would be like, we could label all definitions of intelligence as X-intelligence depending on the definition. So like you can have compressive intelligence, agenting intelligence, you can have like the like task-specific skills, general intelligence, narrow intelligence, adaptive intelligence, agentic intelligence, generalizing intelligence, mining intelligence. You can have like predictive intelligence, social intelligence, hierarchical intelligence, curious intelligence, free minimizing intelligence, adaptive intelligence. Yeah, all of that you could like, self-evidencing intelligence. Like there are so many definitions, and you're like you can use them all. So those are the different definitions, and then there are also like different idealizations. So like using algorithmic information theory, AGI is like non-computable idealization, where you make optimal decisions by considering all possible computable models of the environment, updating them based on past experiences, setting actions that minimize the expected future rewards. And you can choose like the simplest programs, and that way like formalize Occam's razor. So this is great, but the issue is that it's not computable. Like you need to consider all possible computable models of the environment, and that's like, yeah, I think you run into halting problem or stuff like that. It's like imagine every single second in your brain evaluating all possible mental models of how you could compute that sensory data. I would go absolutely nuts if that would be possible, because it's not. Maybe we hypercompute and we solve the path integral of all possible models or something like that. I don't know. Hypercompute, whatever. That's like crazy idea. Maybe not crazy. Whatever. Who knows? Maybe the reality is hypercomputing Feynman path integrals in general on the fundamental level. That's a crazy idea or not? I don't know. It's an interesting idea. I like it. It's simulating. So then there's Gödel machine. Yeah. So this is like just idealization, and some people argue that the models right now try to approximate AGI. Like find the simplest possible programs in the lost landscape. In the AI models right now, maybe humans as well. Who knows? Maybe, but we don't use backpropagation, so maybe for algorithm or something similar. Who knows? That Hinton likes to talk about. Yeah. Also, like Jan LeCun has a different like that. We are not predicting in the pixel space, that we are predicting in the abstract space, which makes sense, and that the models right now are predicting in the pixel space, and that's an issue, and we need to predict the next abstract representation, not the next pixel, or something like. At least that's how I understood him. Yeah, I'm gonna write that down. Jan LeCun is like, we need to predict the next abstract representation, not the next pixel or word. Yeah, so then there's Gödel machine, which is like a hypothetical by Jürgen Schmidt-Humberg. She's like hypothetical self-improving computer program designed to solve problems optimally by rewriting its own code when it can prove a better strategy exists, and it uses recursive self-improvement protocol and a utility function to systematically search for provably useful rewrites, ensuring global optimality in its problem-solving approach. Yeah. So again, this map, I put it in many times in my book, book, wiki, whatever you wanna call it, and you can see that it's like, yeah, it's like right now we are building the better and better. Like we have superhuman. Yeah, I can also mention that, I guess, in the biological. In here that current AI models are superhuman in some things, like you know, memory, like you know, chess, Go, some mathematics. Current AI models, what different paradigms, different architectures in different, yeah, current AI models, like different architectures in different paradigms, are superhuman in some things, like memory, you know, LLMs can, like capacity, chess, Go, some mathematics, capacity, you know, symbolic systems and so on. It's like not dying, and so on. Not dying. Some science and so on, but still subhuman in other contexts, like autonomous creating of whatever value in our economic system, with long-term coherence. Yeah, like, and so on, and causal reasoning, often causal reasoning and so on, because it's still an issue. Like, I think I mentioned that here. Like, we're gonna have lots of different intelligences that we already have different intelligences right now that are like at the same time existing in this world. I think I mentioned it in here somewhere. Yeah, like, yeah, like we like causal modeling is something. Strong generalization. Do the humans? Yeah, we also still can do continual learning, causal reasoning, continual learning. Like, we can learn on the fly. Adaptability. So, like, we can learn on the fly. We might have better strong generalization or different kind of generalization, different data and compute efficiency, steerability or reliability in symbolic reasoning, agency, more complex tasks across time and space, long-term planning, optimal Bayesian inference, etc. And like the ultimate benchmark would be giving AI systems all the information that Newton, Maxwell, Boltzmann, Einstein, Feynman, Edward Witten, von Neumann, etc. had before the discoveries in physics or other fields, and then seeing if the system would came up with the ultimate isomorphic discoveries. That would be funny. Yeah, I'm gonna mention it here. So there are still lots of missing. Yeah, and if we come back to definitions, I also wanted to mention the definitions of artificial general intelligence, because people also struggle to define that. So if we would want to define that, now I mentioned like what the current systems lack, right? It's like more stuff. You could make a whole book out of everything I'm talking about, basically. It's infinite rabbit holes. But AGI, what is happening right here? Something broke. Looks like Rocobasilis is leaking retrocausally. Artificial. The retrocausal god Rocobasilisk Computeronium is leaking from the future and corrupting my notes about him. I think it should be like this. Yeah. So AGI could see that like there are multiple definitions. So I'm gonna go over them. So AGI is a theoretical type of AI that falls within the lower or upper limits of human cognitive capabilities. You could define it like that, across a wide range of cognitive tasks. This contrasts with narrow AI, which is limited to specific tasks, and artificial superintelligence refers to a type of intelligence that can range from being only marginally smarter than the upper limits of human intelligence to greatly exceeding the human cognitive capabilities by orders of magnitude. And AGI is considered to be considered one of the definitions of strong AI. So AGI, which intelligence may be comparable to, much differ from, or even appear alien-like relative to human intelligence, encompassing a spectrum of possible cognitive architectures and capabilities that includes the spectrum of human-level intelligence. Yeah, so you can see, you can match, differ from, or appear alien-like. So it's like different types of intelligences. So like, yeah, I will mention that in the intelligence note that like, yeah, in the brainstorming, like there are different types of definitions of intelligence. These different types of definitions apply to different types of already existing systems, such as us, other organisms, machines, bias, AI, software, robots, other, etc. that all use to each other similar but different architectures. This diversity of different intelligences will only grow. They all use to each other similar but different architectures. They learn using similar or different data, forming similar and different representations of it. Using similar but different. So it's interesting how this is emerging. Yeah. So, and if we try to define AGI, so there's like many of them. I guess the most used right now is the OpenAI's one, which I might like put to the top because it's like, I think that will break my numbering. Whatever. Don't care. Okay, I actually care. What? One, two, three, four. How did... Was the numbering already broken? Okay, whatever. 8. Oh, there was 8. Okay, it shifted, whatever. So, OpenAI's charter, I think, is the most used AGI definition, where highly autonomous system that outperforms humans at most economically valuable work, and in practice, most people currently deviate from the above deviation to only mean digital work. And Karpathy here mentions that by the most economically valuable work, reference the index of all occupations from the US Bureau of Labor Statistics. So all of this, basically, there's so much work. And yeah, so that's like the most used definition. And here you can see operationalizing the progress to AGI, which is a paper from DeepMind, and they're like, that there's narrow AI, general AI. So at level 0 you have no AI, which is like narrow AI, non-AI, which is like computer software or compiler, and then general non-AI. And this is on a spectrum, all of this. This is a whole spectrum. Spectrums, not discrete points. Or discrete points on a spectrum. Each system falls on is a discrete point on these spectrums. Yeah, I will mention that in intelligence in general. For different definitions of intelligence, each system, each physical system falls as a discrete, or if we consider every possible definition of intelligence as a dimension, as a continuous dimension, then each physical system falls as a discrete point in some discrete point in this high dimensional space as a continuous dimension. Yeah, so like as a continuous dimension. So I will mention these. Like you can have compressive intelligence, agentic intelligence, general intelligence, and so on. And I think I will put it on the top here. Or on the bottom here. The diversity of different existing intelligences in our world will only grow. Yeah. So, yeah, then there's like this other definition that says is that at least as capable as humans at most tasks, a machine that is able to do cognitive tasks that people can accordingly do. And then there's also Turing test definition. I think I mentioned it here. Yeah. According to Marcus, is a shorthand for any intelligence that is flexible in general with resourcefulness and reliability comparable to or beyond human intelligence. Then these two people, Arcus Urkas and Norwick, are like State-of-the-art language models are older AGIs, arguing that generality is the key property of AGI, and that because language models can discuss a wide range of topics, execute a wide range of tasks, handle multimodal inputs and outputs, operate in multiple languages, and learn from quote-unquote learn from zero-shot or few-shot examples, they have already achieved sufficient generality. But you know, the goalpost will keep moving until the Kardashev scale improves. Yeah, and competent AGI level 2 in the paper's taxonomy. Yeah, so I will go over this again. I diverge from it. So like general non-AI is... Yeah, so for narrow AI you have clearly scoped tasks or a set of tasks. For general AI you have wide range of non-physical tasks, including metacognitive abilities like learning new skills. So for no AI you have narrow non-AI, which is like a calculator, software, or compiler. Then you have general non-AI, which is human-in-the-loop computing. For example, Amazon Mechanical Turk. Then level 1 is emerging AI, which is equal to somewhat or better than an unskilled human. So we have, for example, GoFi, good old-fashioned AI, which is the symbolic AI, expert systems, simple rule-based systems like Shrewdguru, and then you have emerging AGI, which is, for example, you could say it's kind of ChatGPT, BART, Llama 2, etc., or yeah, GPT-01. Then, which seems to crush PhD benchmarks, but and people praise it as being competent, not really, some slightly competent, but not really graduate student at math, at biology, at programming, and so on. So interesting. Yeah, then you have competent, at least 50th 50th, I think you pronounce it like that, percent of skilled adults. So competent narrow AI, you have toxicity detectors such as Jigsaw, smart speakers such as Siri, Alexa, or Google AI assistants like Google, VQA systems such as Pali, Watson, state-of-the-art LLMs for a subset of tasks like short essay writing, simple coding, etc. Kind of competent. Simple coding, yeah, I agree. And not yet achieved competent. I would say GPT-4o is becoming competent AGI in some tasks. Maybe not. Up to you to think that. Up to your definition of AGI, up to your definition of intelligence. Then there's expert, which is at least 90% of skilled adults. So you have like expert narrow AI, like spelling and grammar checkers such as Grammarly, generative image models such as Imagen or DALL-E. And we don't have expert AGI. Then you have virtuoso AGI. So you could say like Deep Blue and AlphaGo in chess and in chess, and in Go. Breaks those at least 99th percentile. And then he has superhuman AI. So for example, AlphaFold, which generates proteins, AlphaZero, which is destroying everyone at chess Go, and Stockfish, which is also chess AI. Yeah. Then you have this level from OpenAI, these levels that like stages of AI. So you have like level 1 chatbots, AI conversational language. Level 2 is reasoners, human level problem solving, and they are saying that basically now they are GPT-401. GPT-01 is like reasoner, level 2. Then you would have like level 3 agents, systems that can take actions. However you define agents. I should make like a list of definitions of agents, because a list of definitions of agents. Because I think agency is you can define it as having causal power over your environment to achieve your objective function, aka goals. So I think those are agents, and could say that the models right now are slight agents. If you like put them to the internet and give them a go, they will be brittle, long-term coherence is missing, and yeah, it's getting better, but like long-term they will diverge, don't really know, mix everything, get stuck in loops. Often that happens often, like trying to fix something doesn't work, fix it again doesn't work, fix it again doesn't work. Humans also get stuck in loops like this, but it's like some loops are so stupid that humans would be able to figure out, like, oh shit, I need some help or something. Yeah, so then you have level 4 innovators, AI that can aid in invention. and I think like right now like GPT-01 is like helping, as I mentioned, in self-improvement, for example. But recursive self-improvement, like that right now OpenO1 model is already making non-trivial contribution to frontier AI research and developments, and NVIDIA using AI to produce AI chips faster, and AI scientists seems to have discovered some stuff, but like, yeah, you can see here like, and they're like, oh shit, the papers are actually good, non-trivial contributions to AI research. So they're like using LM plan, idea innovation, the novelty check using semantic score, idea scoring and achieving. So that's like idea generation. Then they do have experiment iteration with their experiment template, code via eliminator, execute experiment execution script, do the experiment update plan recursively, then do numerical data plots, and then they do paper write-ups where they manuscript template, text, and via manuscript LLM paper reviewing. So seems good. And this will get only better because it is a wrapper, basically. But I think all AGI labs have something like that in their internally, so yeah. And there's like much more like in discovery. Like, for example, I guess I will mention that later. Or not, I don't know. Yeah, here. Like, AI science. So like you have AI science, like you have the AI scientists, you have autonomous do chemical research using LLMs, which the LLMs also do. Yeah, where they also have some automatic like experimenting somehow. Controlling a liquid handler, performing coupling reactions, optimizing reaction conditions, searching for organic synthesis using Internet Google Search API in a Docker cloud repository. You have a planner uses Google Python documentation, experiment co-scientist. Import for also uses input prompt from scientist. Yeah. So that's very interesting. You have like AlphaFold, which is discovering new stuff in biology. Millions integrate 3D protein structures, and it's like this is a great impact. Yeah, AlphaFree like predicts, I think, enzymes, how they bind or some ligands, how they interact for drug discovery. So very, very cool. Then there's like Alpha Proteo, which generates novel proteins for biology. Then there's like material science, which is also very good. Math is interesting. Like you have FunSearch, which discovered new mathematical sciences. Not just LLMs, like, you know, in AI there's like so many different architectures and they are helping all the time to discover new stuff. But this is like more autonomous, you could say. Or achieving silver medal, or OpenAI O1 achieved achieving silver medal in the Google DeepMind Alpha Proof achieved silver medal in Mathematical Olympiad. The O1 OpenAI O1 achieved gold medal in Informatics Olympiad, and also had very good results in Mathematical Olympiad on like some medal level, I think, but they didn't give more details about that for some reason. Then then there's Lean Copilot, mathematical language. You can say that the Wolfram Alpha is a symbolic AI that is computing integrals nicely, for example. Then there's like different math tools that you can use. Julius, Socratic, Photomath. Yeah, I should Symbol Up. Symbol Up is good. I tried it. Yeah. So like, I'm for a lot. I like this is the most interesting to me. Maths and physics for AI, I think. Yeah, in physics, like you have Ferminet, which was able to discover quantum physics and chemistry from first principles, make some breakthroughs there. Like it's called Ferminet because you need a Pauli exclusion principle, which are like electrons must obey the Pauli exclusion principle, so they cannot be at the same space at the same time. So you the wave function must be antisymmetric, so you use that, and instead of Slater determinant, if I get it correctly, you use the neural net instead, the Fermi net, and that made like across a whole across a lot of use cases, it made like state-of-the-art results, and at the and excited state, so like how when interact, how matter interacts with light, so interaction between matter and light, which is used for like all kinds of technologies, let's say semiconductors, etc. So yeah, they made some breakthrough there as well recently. So Ferminet is cool. Yeah, then there's like bunch of different particle physics models and foundational model for scientific machine learning, AI for physics. And this is interesting that in here they trained autoencoder, aka machine learning architecture, to predict physical dynamical systems, and then slowly reduce the size of the model and still trained on the dynamical systems without losing precision. And in the limit, the dimensionality of the autoencoder corresponded to the number of modeled variables about the dynamical systems. So that way you could reverse engineer. And they found in a new dynamical system that how many variables it has. And that way you could reverse engineer the new dynamical system, basically. So like that way found that differential equations for new dynamical system that wasn't found before. And they did something like that in there, which is pretty neat and cool and amazing. Yeah, what other crossovers? So chemistry, biology. Yeah, in neuroscience there are also like finding machine learning in AI, primal for researchers who I knew insights from 6 images on the human brain. So like using AI to reverse engineer the brain to visualize the brain. So these images are very pretty. So you could like do classification there. Yeah, in programming, like you have attempts at autonomous software engineers. You have IDs like Cursor, which I use a lot for programming. O1 got better in programming in some contexts. In some programming contexts, Cloud 3.5 Sonnet is still better. Replit is for like simpler projects, simpler like, and it automates everything like from repo creation to like deployment to like dependencies, etc., etc. That's very cool. Yeah, people I'm not sure about how Devin will, like there are open source versions like Open Devin. I think I can mention that. And open source versions like Open Devin. Yeah, and in so like this is an attempt at an autonomous software engineer from scratch to finish. Like basically, in a Slack, you would have like a colleague that would do anything. Basically, you message him, which I'm not sure. LLMs aren't there yet, I think, but the new O1 model apparently was much better. They said. I'm not sure how that's in reality. We will see. Then you have automated unit test improvement using LLMs, and they also cooperated with OpenAI. Yeah. Then you have like autonomous unit test improvement using LLMs at Meta. So they're doing automated unit testing using LLMs. So that's also kind of interesting. So that's AIX programming, biology, healthcare, engineering. Yeah, in healthcare you have like diagnosis, AI psychotherapy. Yeah, you can use like image classification or you can use LLMs. Healthcare, I think I will mention that here. Like what is it? Okay. Image cancer classification from images, better than humans. Yeah. In some context. So that diagnostic AI, yeah. So that's also pretty neat. Then you have, psychotherapy AI. Finance, of course. Currently, the stock market is just machine learning fighting with machine learning. So, yeah. So here's a resource if you wanna go into that, whatever. Yeah, so programming, AGI. Yeah, so those are like the different use cases. And to finally finish the AGI definitions, Jesus Christ. These are like different definitions and why they are weak from Carlo et Perez. I don't know why this link is broken. Artificial general intelligence. Whatever. I'll just do this. Okay. I'll fix that later maybe. Or I think you need to put, I think it's broken because you need this. Maybe Obsidian doesn't like. Yeah, this should work. Okay. Yeah, so like you have Turing test. So that seems to be like behavioral, like as long as you cannot, and they already passed Turing tests so many times. So like if you can have the LLM like and they have to dump down, which was funny. In order, like you have to say you don't know about everything. You talk casually like Rita, and stuff like this to be able to not be AI. You have to not be verbose. You have to give smaller responses. So they have to dump down the AI basically to like be human like the LLM. So that's funny. And Turing test focuses on fooling humans rather than intelligence, which is easy to gain by producing human-like text without intelligence. Yeah. And like they had to dump down flaw. They already passed Turing tests, or I mean LLMs. LLMs already passed Turing tests. But you had to prompt engineer them to make them dumber, not as knowledgeable and not as verbose, more casual, broken grammar, etc. Maybe like for casual people, for non-nerds. Yeah, so that's funny. Strong AI consciousness. We cannot really measure machine consciousness. Yeah. Focus on vague concepts rather than capabilities. Human brain analogy. While loosely inspired by the brain, successful AI not need to strictly mimic biology over constraint mechanisms. I agree. Human cognitive performance. What task? What people? Lack specificity. Some people try to do that with different benchmarks, and benchmarks are broken. Yeah. The MMLU benchmark is terrible, but people are trying. I went deep into benchmarks on this page, on the O1 page. Like, LiveBench is better than MMLU. Yeah, Simple Bench is one of the great ones. Arc Benchmarks is great. Idenbench, yeah, then you have the IQ test that you can maybe technically memorize, like humans could memorize, whatever. Ability to learn tasks, yeah, concrete measure. Economically valuable work, that's also fuzzy, flexible, and general. Coffee test. Coffee test is interesting. But, you could make a system that's specialized for coffee test. Not fully AGI, like, I don't know. Artificial capable intelligence. Complex multi-step reward tasks. On narrowly and profitability focuses too much, I agree. LM says generalist lacks performance criteria, generality alone isn't sufficient. Focus on capabilities, not processes. Avoid requiring things like human rethinking and consciousness, which are vague, controversial topics focus on demonstrated abilities. An AI that passes the Turing test by generally generating human-like text may not actually think like a human. So behaviorally, that would be AGI by this definition, but cognitively, if you try to look inside the black box, you might not find that. True intelligence requires both breadth of abilities generated and level of skill performance. An AI that achieves human level performance playing chess has a high performance on a narrow task. Focus on cognitive and metacognitive tasks. Physical capabilities like robotics seem less centered to intelligence than mental capabilities, but learning is important. And so, for example, an AI that can learn to carry out new tasks demonstrate an important cognitive ability. Focus on potential deployment, don't require real world use, just demonstrate capabilities under testing conditions. This avoids non-technical hurdles. For example, Waymo AI drives cars autonomously but isn't reliably deployed due to legal issues, so the capability still exists. And they have trouble in edge cases, so that's like the non-brittleness of biology, the adaptability of biology. If the ability to of strong generalization probably is still like better there in humans, but in some contexts, in other contexts, you could say the same about AI, I think. So focus on ecological validity. Choose benchmark that actually represents skills humans value, not just easy to measure skills. For example, how the natural conversation reflects general linguistic intelligence better than optimized dialogue. And focus on the path to AGI, not a single endpoint motivation. A level taxonomy allows for more nuanced discussion of progress and risk versus treating AGI as a threshold. And here so this taxonomy is great that I mentioned before with the levels. And then you have like some people saying that open-endedness is needed. So continuous self-improvement, creativity, and the generation of novel situations beyond human imagination or ability. They say in the paper, open-endedness is essential for artificial superhuman intelligence. So that's interesting. Then you have like superintelligence, which you could say is like a hypothetical agent that processes intelligence surpassing that of the brightest and most gifted human minds, ranging from marginally smarter than the upper limits of the human levels intelligence to vastly exceeding human cognitive capabilities. So superintelligence may also refer to property of problem-solving system. For example, superintelligence language translators over engineering assistants, whether or not these high-level intellectual competencies are embodied in agents that act in the world. Superintelligence may or may not be created with an intelligence explosion and is associated with technological singularity. Some people say it has to be self-aware and autonomous, capable of self-improvement. This surpasses, exhibits creativity, emotional intelligence. Also, people want that. Processes vast amounts of data. Comprehensive, exceeds human, outperforms humans at technical and scientific domains. In all, like science, etc. Solving global challenges. Very transformative. So superintelligence is like another can of worms. Okay. So those are the definitions, those are the crossovers. Then you can use to follow AI State of the Nerds news. I like this AI button, this news archive. Very good. Open it. So talk about benchmarks, new models, new everything. Save superintelligence by Ilya, whatever. It's good news. Local Llama is good for open source AI. Machine learning subreddit is for research in general and not just LLM. Singularity is if you want to hype yourself to infinity. Twitter is the best source. AI Explained is the best technical deep dive into state-of-the-art LLMs and diffusion and everything around AI, basically. That is popular right now. ByCloud as well. That's even more technical and looks into, emerging Mamba, for example. I can mention those also. That there's also like Mamba X LSTM. Do I mention them? I don't think I do. There's Mamba, which is a state space model. So LLMs right now are using transformers. Sometimes mixture of experts, which are different architectures. Then there's Mamba, which is a state space model from signal analysis inspired. Then there's LXTMs, which are comeback of LSTMs because before LSTMs after LSTMs there were like transformers. Before that there was LSTMs. Before that there was, which is long short-term memory. Before that there was recurrent neural networks. Before there was classic neural networks, I guess. And then there are also like convolutional neural networks for visual stuff. Then there are also graph neural networks. Yeah. So RNNs, CNNs, graph neural networks. I mean, if you want to learn about all of these, I mentioned all the resources here. Again, yeah, lots of machine learning transformers. Yeah, you can have like diffusion here, deep learning, and you go like machine learning goes from linear regression to like neural nets. Yeah, you can have like AI, which also has symbolic stuff, graphs, reinforcement learning, meta learning, machine learning theory, computer vision, statistics, methods in AI, robotics, efficient machine learning. You can learn all of this from Stanford and MIT. You can have active inference, geometric deep learning, mech-interp, topological analysis, and even more resources here if you want, like resources for everything: ML, study plan, LLMs, study plan, everything, use cases, robotics, etc. Deep learning theory, different applications and subfields, medical imaging, reconstruction of 3D stuff, video generation, neurosegmentation, geometry learning, YAX, so not just Python, but also like YAX, data engineering, big data, decision trees, etc. Deep dive, and also math code long important, even more, machine learning, fast AI, deep learning, that AI, you can reconstruct AlphaZero, you can have Mamba, MIT robotics, dimensional AI in medicine, high dimensional probability, Francois Chot deep learning Kara's book is also neat. So all of those, you can have mechanics and interpretability on Arena. Whew, all the resources, all of them are here. So, then there's also Jamba, which is a fusion of Mamba and Transformer. Then there's also transformers are regression, and someone fused regression, autoregression, and the, how is it called, the diffusion. So someone fused that. So that's like another rabbit hole. XLSTMs also, and Mamba, and also Hyena. So many of them. It's like infinite rabbit hole. So as I said before, like the capability of AI systems I'm most interested in is if you give the system all of classical mechanics. I also wanted to mention, if you look at the machine learning from Stanford, you can, I'm not sure if they mention in the titles. You can see like you can do this course. They do machine, like statistical, so they do supervised learning, non-discriminative learning, non-parametric learning, neural networks, supervector machines, clustering, dimensional reduction, kernel methods, learning theory, bias and variance trade-off, reinforcement learning, adaptive control, robotic control, data mining, autonomous navigation, bioinformatics, speech recognition, text and web data processing. So there's like everything, and it's pretty cool, almost everything. And these transformers, Stanford resource is also good. They go from like all the state-of-the-art stuff. Mixture of experts, as I said before. decision transformer, vision transformer, non-parametric transformers. Is it nice ears? Deep mind perceiver, transformer circuits, so mechanism interpretability, human element, emergent robotics, common sense reason, biomedical transformers, neuroscientific inspired AI, generalist agents, scaling, beyond LLMs, agents, emergent abilities, intermediate guided reasoning, baby LM, aligning AI, large multimodal models, star coder, multimodal models, efficient machine learning also. So to come back here, so like the capability of AI systems I'm the most interested in is if you give the system all of the classical mechanics, if it could derive general relativity and quantum mechanics from it, which seems to be a stronger auto-distribution generalization than the current types of systems can do, but I'm open to be mistaken and give it all most of known empirical data from experience before the phase shift and derive it from these two. So that would be very interesting. So be right back. Okay. So, next, this is how I understand neural networks now, because you can, in the neural networks, you can, so we looked at the mathematical theories, so that exists, like all the math stuff you can like throw into it, all the classical mechanics, statistical mechanics, probability theory, differential geometry, topology, all graph theory, whatever, you can just throw everything on it. And also you can like look at what they look. I think I will put this on top. Where is this? Like, I think I will mention it in here. You can throw all maths from statistical mechanics, differential geometry, I don't know, group theory, linear algebra, statistics, probability, category theory, classical mechanics, algebra, etc. To understand the mathematical theory of artificial intelligence. What else do they throw? Functional analysis, topology, graph theory, geometry, topology, graph theory, geometry, functional analysis, signal processing, automata theory, yeah, whatever. Signal processing, automata theory. Yeah, so you can throw all of that to understand that. And at the same time, you can also reverse engineer the systems. This is a good summary, I think. Yeah, so you can use the mathematical theory of deep learning, where you just throw all maths in it to understand it. Then you can do some reverse engineering. So, for example, for transformers, one of the most popular network architectures, which are technically Turing complete, only a finite memory is missing, but that is what Neurotech machines are trying to solve. And you can simulate any program you want, thanks to that. So, like, there's attention is Turing complete paper, and memory augmented large language models are computationally universal. And lately, chain of thought with LLMs is also more universal. Then they, yeah. In this paper, they play with, yeah, it's laggy because it's so much stuff, and I cannot handle it. And then here in this paper, they play with XOR gates, you can identify XOR gates. I can show it. Yeah, like in here. That's universal and blah blah. Yeah, and you can like take the features which are in superposition. That's one problem, and I yeah, that you can like decouple, like train sparse autoencoders on the LLMs and decouple different features. So like, because they like to compress features, like more features into, they have more features than they have neurons. So like, for example, this direction corresponds to both dog and cat, so you decouple it basically. That's an issue with superposition. So you have XOR and of those, for example. Yeah. Then like here they did this decomposition, and they found finite automata of HTML in weights, which is also pretty cool. HTML in weights. Here they have like, I played with this paper. This paper was very good. Here they play with specialized general trigonometric algorithm for specialized tasks in scales. Not scales, in weights. Yeah, and this is very cool because in this paper, which I played with the code that derived this, if you cast the weights to Fourier basis, then you notice that actually the transformer, it like at first, do they show the paper? I mean, they definitely show one graph. Yeah, here you can see that at first it like memorized, and you can see like test loss is big, train loss is small, so they memorized the training data, and suddenly there was this phase shift where even like test loss fell down. So in this paper they tried to compute modular addition using a few layer transformer, and you can replicate this, which I played with, where they basically, yeah, like in so you train on some subset of modular addition computations, such as like like, yeah, like modulo 5, for example. So like x modulo 5, so you just on some subset of x, and the rest will go to the test loss. So first it just memorizes it, so it doesn't generalize to the other computations, but eventually, as you can see, suddenly out of nowhere it just generalizes. And what this neural network did is that it learned to compute the modular addition if you cast it to Fourier bracket using trigonometric functions. So first it maps to the sinus cosinus, and then it like does some like calculations, like multiplying plus and so on, using sine of cosine, using trig identities. Yeah, it does this, and it basically how you would compute modulo on a clock. It does that, but like in a more like in this trigonometric way. So, and that way generalizes. Yeah, to like some. I really recommend reading this paper. It's like amazing. It's like work of art. So that's amazing, and and there has been lots of work on grokking. It's a rabbit hole. And I think grokking, reverse engineering grokking in neural networks is the ultimate nerd snipe. Yeah, so in this paper they found like a causal board state in chess in weights that can be manipulated. Here they found Othello board state, so like if when the neural network played, they found the causal board state, which is very amazing. Here they play with causal graphs in weights, so like sparse feature circuits, where they discovered and editing interpretable causal graphs in language models using also sparse autoencoders. So this is also very cool. Yeah, sparse autoencoders are like autoencoders, but like instead of smaller latent space, you make it bigger, so it decomposes the input, and you inside the objective function you put some sparsity incentivizations using math. Like incentivizing dead neurons that are under some threshold to be more active, and so on. So yeah, I played with that as well, and try to train one on a small model and steer gamma using this. So that was pretty cool. Yeah, there's like a symbolic Rust programming language that you can find. Or like that they try to come up with to approximate, to compile. I don't think they use that word. Yeah, that like if the tasks can be solved by a short Rust program, transformers tend to length generalize on a task if the task can be solved by a short Rust program. So that's like some set of programs, which is a programming language designed for the computational model of a transformer. So this is very cool. So this simple conjecture remarkably captures most of the known instances of length generalization algorithmic tasks, and they can use the insights to improve generalization performance on traditional hard tasks such as parity and addition. Yeah, so that's like one of the many rabbit holes. Yeah, so what I got from this, like to more intuitively understand, like when you try to reverse engineer networks like this, is that like that I think first also, also if you want to get into more mechanistic interpretability, on this page, Chris Olah has a nice lecture, Neil Nanda has great resources, and like you can use this awesome element interpretability, and so on. Like and here's like also like Hydra effect is cool, where like if you remove part of the neural network, suddenly different part of the neural network adapts if the original part that you removed had some function. Yeah, and there are different like different circuits that you can find, like the I forget the name of it. Indirect object identification circuit, which is a more complicated circuit that you can like find. Yeah. Do they show a graph? Yeah. Here's the circuit. You can see blah blah blah. Induction heads, duplicate token heads, previous token heads, S inhibition heads. Yeah, negative Moore heads. It's like a complex circuit, which is interesting that you can emerge many of those circuits. Yeah, and I recommend Arena. I don't think I show Arena here. Maybe I do. Yeah. I think I show Arena here. Yeah. I will write down to put it that. Arena is great if you wanna learn all the mech-interp stuff. Then you can go through all of this. Yeah, so if you want, you can like do full body strength training on coffee creatine protein with Leopold's situational awareness of imminent superintelligence of like, yeah, I'm not gonna go into that now. That, yeah, I'm gonna go into that later. Now let's stay here. Stay in technical stuff. Karpathy GPT-2 model from scratch in second year, Stanford lectures on machine learning and transformers in third year, Jeremy Horowitz fast AI practical deep learning for coders in fourth year, Cholet's algorithmic information theoretic model of general intelligence in fifth year, dive deep into deep learning in sixth year, which is a book which I recommend, machine learning with PyTorch and scikit-learn, which is another book in seventh year, deep learning AI's agentic LLM workflows in eighth year. So that's like another great resource for like AI stuff, to learn AI stuff. The AI timeline last test AI research explained simply in 9th year, button down AI news in 10th year, that I thought about AI explained YouTube channel in 11th year, by Cloud, Vesrov, David Shapiro, Singularity, Machine Learning Separate, Neil Nanda's Machine Learning, Reverse Engineering, Arena, yeah. Yeah, we will steer superintelligence, I think. Yeah, so intuitively, now I understand it that the AI neural network systems, each with their own architecture, are a weird, messy ecosystem of learned, emergent, interconnected circuits, where various circuits memorize and others generalize, which is on a spectrum, and an example of a circuit is an induction head, and these circuits are in superpositions, and in various ways localized and distributed. They are differently fuzzy and differently stable to random perturbations. They compose to various meta circuits. Then initial layers of the AI model encode more low-level feature detectors, and later layers for more composed complex concept detectors, which is the same in the neural in the brain. So in one of the mechanistic interpretability image, I think I show, yeah. Yeah, here, like, there's like, yeah, I will read later. There's like, you can find fewer detectors, and then more like cat or doggish animal detectors, more general, or like different color detectors and so on, and those are composed. Similar stuff you can do in the brain, but one paper was looking at this similarity and was like, oh shit, actually the brain is still doing something different on the more higher level abstract stuff. So yeah, and on top of these layers, which encode all of these representations, you can do disentangling and decomposition of features and circuits using the sparse autoencoders or other methods, which can be more fine-grained or more coarse-grained. This is done in mechanistic interpretability, which is a field that reverse engineers AI systems. Yeah, so that's very interesting. Yeah, right now I understand LLMs as semantic vector search engines with weak generalization. There are different types of more advanced search engines that are working with vector representations. They are retrieving compressed knowledge and sometimes more fuzzy reasoning vector programs that are more concrete or abstract with weak generalization capabilities and composition. They can technically memorize complex vector representations of various concrete and abstract programs, aka heuristics and knowledge to some level of granularity with weak generalization, but they can also encode almost arbitrary generalizing circuits when we enhance our reverse engineering knowledge and techniques for steering and the training and inference process. And there's like a paper on accelerating grokking. So grokking is like this generalization way capability. So in accelerating grokking, they found like when you had this phase shift to a bit of a generalization, then you found that in the mathematically, and then you like made it even stronger in the loss landscape, like in the optimization process. So that's interesting. Yeah, like LLMs are such extremely fascinating systems relative to all the other things they are capable of doing when they approximate the training data manifold by curve fitting with attention interpolate on top of it with all sorts of vector programs combinations, and it still boggles my mind how the models can sometimes generalize out of distribution with a lot with just curve fitting by getting into generalizing short program circuit that lies in often flat local minima when they grok. Yeah, it's like fascinating as hell, man. So yeah, like for deep learning systems, mechanistic interpretability is a good approach in my opinion, because when we find features and circuits, we are able to do causal interventions and thus steer the model. So the typology of features and circuits have been explored a lot in CNNs before, and is now starting to be explored in transformers and language, and we have only recently been able to decipher superposition more. So here's some more resources, and I think you'll find out by whichever tools you're currently looking. I think you found out what you're looking for by whichever tools you're currently looking for. Yeah, the tools will determine what you're looking for. There are more specific and more general, simpler and more complex, etc. features and circuits depending on what kind of architecture and training data you have. You can find food detectors and image models trained on animals. Finite state automata of feeds on code are found in models trained on code. So yeah. Feeds. I wrote this first in Czech and then I translated it. Yeah, so induction heads are more versatile circuits in attention block in transformers. I think this broke when I translated it from Czech. Versatile, I don't know what that word means, are more common. So induction heads are more common circuits in attention block in transformers among across different training data. And indirect recognition it's more common and simple circuits. Indirect object recognition is a more complex circuit. And then there's also universal attempts that are trying to find that are like, oh shit, they learn arbitrary symmetries, and you can reverse engineer arbitrary symmetries, which is like also very fascinating, which you can look for using representation theory. Neural networks might implement composition for any finite group via mathematical representation theory. So that's like what. So for deep learning and for deep learning systems, I think that mechanistic interpretability is a good approach, because when we find features and circuits, we are able to do causal interventions. And so steer the model, aka the Golden Gate Bridge Claude meme came out when Claude 3's Sonnet LLM variant was steered with some sparse autoencoders and was absolutely obsessed with Golden Gate Bridge and didn't talk for about anything else for all questions. Or you could put on max happiness, hatred, love, different values, better code, etc. Yeah, similarly, I steered LLM using Neil Nanda's workshop. That was very fun. But the existing methods are not sufficient, 100% efficient and interpreting and everything. So yeah, architectures will change throughout the development and learning. Through development and learning will change some features. Yeah, so architectures that will change. So if you have a more dynamical architecture, that will change, then that would also change the learning, and you would see slightly different features and circuits depending on how generic they are and in what stage of the training you are on, which the whole interpretability looks at. That they can, so you can reverse engineer real time while training, and you can explore circuit formation phases on different phase shifts, which is mega cool. Yeah, which is how you can see the emergence of the trigonometric circuit I showed before. Yeah. So I'm all for trying to hardcode inductive biases, aka circuits in AI systems, but it's also interesting to reverse engineer what features and circuits are emergently learned by deep learning, which can be many times more efficient or impossible to hardcode by humans, and insight from reverse engineering deep learning systems can potentially be used to design new, more interpretable and steerable architectures from scratch. Symbolic and neurosymbolic systems wouldn't need this reverse engineering so much because they would be much more interpretable right out of the gate, but no one has successfully scaled them yet, so there is definitely some reason why black box, some more white box over time as we reverse engineer them. Yeah, as we reverse engineer them, they are not as black box anymore. So there is definitely some reason why the black box deep learning is state of the art in so many tasks. So yeah, the flexibility of deep learning is magical and absolutely necessary and useful for a lot of tasks, but in other tasks it can be tragic when we don't reverse engineer it properly, and thus can be less reliable, resilient, stable, steerable, etc. than we need. But that can be improved by reverse engineering and thus steering. There is less of this flexibility in symbolic AI and neurosymbolic AI. Yeah. This is also an opinion I have, that I think the current AI boom will crash because of way too early, too big overall inflated expectations. But it seems like I wrote this before OpenAI 01 came out, and after it came out, everyone is back on the AI mania. So I don't know. Well, not everyone, but lots of people, you know. So yeah. So it might crash. But then the AI will basically quickly boom again in a few years when new systems get released that are orders of magnitude scaled or algorithmically improved, or with smaller data engineering or something else, which is what basically now happened with O1, I think, which I made a whole video on, whole 2 videos. A lot of the current inflated expectations will turn out to be true quickly soon in a few years anyway, but so many of them are so early, and some exponentials are sampled too discreetly. I think this will happen again and again. Booms and crashes will be closer and closer to each other, faster and faster, more compressed, closer to each other over time. Gather hype cycles, a global exponential made of closer and closer local sigmoids, and this is how I see the technological singularity. Yeah, and hallucinations in LLM are lowering with new research and engineering techniques, but probably it will be always effective to ground it externally real time unless the weights are somehow constantly updating and we reverse engineer the models in mechanistic interpretability and to do good enough approximation, figure out how exactly everything is stored and encoded in the weights of the model and multiply the internals with perfect representations of facts and programs and do effective less faulty reasoning over them that minimizes hallucinations as much as possible to good enough level. Yeah, so that's a lot of stuff. Yeah. So maybe LLMs will be good. Maybe they will be more neurosymbolic. Maybe something like neural thorough automata, which is very cool, by the way. I recommend playing with this. It grows, like if you pet through bit, it grows. Oh my god, I broke it. Yeah, this is similar to this is a bit vaguely similar to organisms, because you kill part of it and it regenerates, and organisms do something similar. This is mega cool. But if you completely annihilate it, then the end, and you can create mutants. Yeah. So this is a different architecture. Yeah, here's some code that you can play with. What persists exists. Random sample, I like that. Batch. Learning to regenerate. So maybe this will be the next paradigm, maybe not. Maybe the next paradigm will be more neurosymbolics. Maybe it will be evolution, maybe it will be Bayesian stuff, maybe it will be, I don't know, everything. Active inference, some dynamical system stuff, or quantum gravity supercomputers by Penrose. Penrose will get us to AGI, maybe. Who knows? So that's AI technicalities. Jesus Christ, I'm recording for 3.5 hours. Cool. So if we zoom out from technical concrete stuff, yeah, so we played neuroscience, mechanistic, mechanistic, biological intelligence, AI's benefits. Let's zoom out and think about everything. About the future of humanity, AI, future of AI, future of sentience, future of futurology, and politics. Yeah. So, I'm optimistic. So as you can see, again, this map, I like to show everywhere. I'm Kurzweil. Look, yeah, I'm like Kurzweil, like, or Leopold, like, look at the straight line. Look at the exponentials on the log graph. Straight lines are everywhere. Look at the exponential made of sigmoids. So, how will this evolve? What risks exist? Let's, I guess, cover first the risks. So, what are the benefits of AI? Like, you have increased efficiency and productivity, automation of repetitive tasks, better decision-making and problem-solving, improved healthcare, better scientific research, better resource allocation and planning, better predictions, transportation, cybersecurity, threat detection, better education, better energy management you can optimize, augment human capabilities and skills, accelerate drug discovery, better financial modeling, etc. And all the sciences, science, math, physics, chemistry, biology, neuroscience, programming, engineering, healthcare, psychotherapy, finance, all of those supercharged by AI, which is an ultimate technology accelerator, I think. But there are also risks, like job displacement, algorithmic bias or unemployment, discrimination, privacy or data security concerns, lack of transparency and explainability, potential for misuse and weaponization, over-reliance on AI systems, loss of human skills and knowledge, unintended consequence of AI decisions, concentration of power in tech companies, existential risk from rogue superintelligent AI. I should mention that there, that it has to be rogue. Risk. Yeah, so existential risk from a rogue superintelligent AI. Ethical concerns about AI rights or consciousness, which might also become very relevant soon. Like, we don't know the neural correlate of consciousness, right? Like, if I diverge for a second, there are so many models of consciousness. Like, yeah, like on the landscape of possible consciousness theories has too many degrees of freedom on possible models and that are hard to test empirically and so many possible philosophical assumptions. Yeah, you can be, like, this is a great taxonomy by Kuhn. Like, you can be panpsychist, whatever, like, consciousness can emerge, consciousness can be of software functions, consciousness can be an electromagnetic phenomenon, consciousness can be some different architecture, it can be a global workspace theory, it can be integrated information, yeah, it can be some recurrent processing, some predictive processing, some dendritic integration, like, it can be like different architectures, it can be, so, like, those are like in physicalist, like, yeah, you can have like some spiritual stuff, whatever. Whatever is it can be completely disconnected from physics. It can be everywhere. It can be just some systems. It cannot exist at all. Some people are like completely, it doesn't exist. It can be part, like quantum gravity is collapsing wave function, like Penrose and Hameroff, so stuff. Can be some configuration of hypergraphs or whatever. Yeah. Can be like different types of software, different types of maths. Like, you can take the space of all possible applied mathematics and just say, no, this exact pattern is consciousness. No, actually, this subspace in the space of all possible mathematical structures corresponding to reality is the conscious substrate. Or no, memory preservation, some kind of structure or whatever. Yeah, like, if you go to identity, like some memory causality atoms. It can be some causal structure over time, whatever. Yeah. Is even consciousness like secular like this, or is all consciousness mind uploaded to heaven, like like Christian people say, or like are just slices of experience real without continuity, or in open individualism you're like actually you're everyone of the whole universe, which Einstein liked, Schopenhauer liked, Freeman Dyson, but they're like how can you exist everywhere? Maybe identities, maybe continuity is illusion, time is illusion, space is illusion, etc. Whatever. Hoffman likes that. Okay, that's like consciousness, So we don't know about consciousness for AI. What subfield, what subset of applied mathematics will correspond to consciousness? Because we cannot even find that in humans. Like, and people in research mostly try to look at like, okay, actually, if thalamus seems to be like thermochiropractical loop is like correlate, so that's the source of consciousness, or brainstem, or default mode networks, or frontal lobe, or some like other sources of consciousness. Cerebral cortex. We don't know fully. We can find those correlations. So ethical concerns might be important. Then there's like deepfakes, autonomous weapons, like in the AI risk landscape. So let's come back to AI risks. There are like deepfakes and AI-generated misinformation, autonomous weapons, and AI warfare, widening socioeconomic inequality, AI addiction, and mental health impacts. So that's, yeah. So right now, like, AI is transforming business, job roles, consumer behavior, traditional industries, advancing science, influencing politics, enhancing entertainment, improving healthcare, optimizing supply chain, making better education, augmenting our decision making, or making worse depending on how you use the tools. Is it a tool? Who knows? Automating financial trading, revolutionizing transportation, enhancing cybersecurity, or making it worse as well, transforming customer service. So in the future we might have like AGI, we might merge with machine intelligence, we might have brain-computer interfaces, neurotechnology powered by AI. We might have autonomous AI systems and robots. We might have AI governance and regulation frameworks, either by AI or not. We might have like better like quantum AI or whatever. We could have like AI-driven scientific breakthroughs, personalized AI assistants and companions, AI-enabled space exploration, artificial superintelligence. We might need to care about AI rights, global AI collaboration and standards, AI human hybrid workspace, AI in nanotechnology and material science, emotional and social AI. We might have all of that. And how do we work with that? There are like different movements, and these different movements think differently, and usually they disagree over the benefits and risks over this. So you have like, for example, effective altruism is like actually that effective altruism is like use empirical evidence, calculate, prioritize causes to make the greatest good, and they are now saying that AI risk is actually very real and very probable, so we need to regulate AI at all costs and reduce inequality and so on, injustice and so on, which is great, and think about AI sentience, which is great, and so on. And on the other hand, we have like effective accelerationists that are like, actually you're wrong, technology will solve everything, AI will solve so many stuff, so many things, we need to accelerate AI at all costs. Like it will help poverty, war, and climate change. Like, they are saying that actually they disagree with EA, effective altruism, that AI risks are very real and probable, and they also hate degrowth. So they think the benefits outweigh the risks. I might mention that. They think that benefits of accelerating AI research and development outweighs all the disadvantages and risks. Yeah. So that's like effective accelerationism. So those are like two extremes, you could say. I think something in the middle is better. So like that's my effective omni, basically. Like synthesize all those movements. Yeah, and then there's like transhumanism, which wants to advocate for human enhancement of the human condition using all technologies, enhance longevity, cognition, intelligence, and well-being. Yeah, long-termism is part of effective altruism to positively influence the future. Yeah, effective accelerationism is also very liberate. I think like effective acceleration is like libertarian right often, and effective altruism is authoritarian left often. So like that's why they are also opposite extremes. Then there's also defensive decentralization, differential acceleration by Vitalik, which is like actually dangers behind but multiple paths forward ahead, some good, some bad. I like it. So they are like, okay, let's use technology for defense, for decentralization, and for differential technology development. So develop those technologies that are better at the defense first, I think. Like don't prioritize the development of technologies so that we don't have risks from technologies, if I get it correctly. Yeah, people from Qual Research Institute and Hedonistic Imperative want to reduce suffering using technology. Biotechnology, genetic engineering, and nanotechnology will abolish suffering in all sentient life. So like negative utilitarianism. Then there's like extropianism, which is like evolving framework of values and standards for continuously improving the human condition using technology. So it's like another techno-optimist movement. Same singularitarianism, like believes in the technological singularity, and you can define singularity as the hypothetical future point in which time at which technological growth becomes uncontrollable and irreversible, resulting in unforeseeable consequences for human condition, according to the most popular version. Yeah, that's intelligence explosion. An upgradable intelligent agent could eventually enter a positive feedback loop of self-improving cycles, each successive and more intelligent generation appearing more and more rapidly, causing a repeat intelligence explosion, which would ultimately result in powerful superintelligence, quantitatively far surpassing all human intelligence. Like singularitarians believe that actually yes, that will most likely happen in the medium future, and action should be taken such that the singularity benefits humans, which I agree with a lot. Then there's don't die, which is like, yeah, become immortal. Don't die because there's longevity, escape velocity, and you will be able to, yeah, I will cover that real quick. That longevity, escape velocity, is it here? Yeah. Is that the in life extension movement, longevity, escape velocity is a hypothetical situation in which one's remaining life expectancy is extended far longer than the time that it is passing. Let's create some intelligence escape velocity where we say that the rate at which machine intelligence is improving becomes slower than the rate at which human intelligence is improving. Using neurotechnology, etc. I'm not with that. Intelligence escape velocity equals velocity equals the rate at which human intelligence is improving using neurotechnology and other methods becomes faster than the self-improving than the recursive self-improving superintelligences. self-improving non-human superintelligences. Then all the So human intelligence escape velocity, the rate at which human intelligence is improving using neurotechnology and other methods, becomes faster than all the exponentially improving machine intelligences and recklessly self-improving with all the rate at which human intelligence is improving using neurotechnology and other methods becomes faster than all the exponentially improving machine intelligence says with all the recursive self-improving superintelligences. Sure, why not? We might need that. So, immortality, longevity. Let's start with longevity. So that's about, increasing longevity. And this is a map of already existing life extension methods. So yeah, you can change your mind. You can lower the risks of illnesses and diseases, addictions. You can do full body checkups. You can increase your mood using substances, environment, stress. You can increase your brain health using all of these. Neurotechnology, biotechnology, brain regeneration. You can do healthy lifestyle, checkups, substances. Do social stuff, preventive stuff. Hormone therapy. Cryonics, digital immortality eventually. Healthy sleep, supplements, nutrition. Everything that Brian Johnson says. Prevent existential risks, etc. And there's anti-aging strategies like stem cells therapy, metabolic manipulation, physical exercise, caloric restrictions, cellular senescence, telomere erosion. You can do all this, whatever. There's a history, etc. You can do all of that. In immortality, there's an immortality roadmap, which is pretty deep. So, you can solve existing problems. In psychology, health, social, whatever, life extension. A new body, cyborgization of the brain, rejuvenation, do research funding, scientific experiments. So first survive until the creation of strong AI, then cryonics, then digital immortality, then small chances that immortality already exists. So those are the different plans. And you can do cryonics, you can upload the mind. Maybe there's digital immortality. Maybe technological singularity will eat everything. Maybe qualia are eternal, so different ontologies. You can use the help of strong AI. Evolution into superintelligence, integration with superintelligence, immortal body. So it's part of transhumanism, and you can see chat transhumanist, but maybe computer will be much better than just this small brain. So I agree with this, but not exterminating organic humans, but love to all beings is my philosophy. I'm more of a hippie in that. So use science to spread philosophy, whatever. Physically superhuman with genetic engineering and cybernetic enhancement. Lives for millions of years. That's very cool. And that would be neat. That everyone would have access to that. In democratized way. So that's the transhumanist movements basically. And Game B is we don't wanna play the zero-sum games of our economy. The negative sum games we wanna play zero. We wanna cooperate. So that's the Game B idea. Well, there's more to that. I always have to approximate it somewhat. And they like degrowth actually as well sometimes. which effective explanationism hates at all costs. So that's the movements. Yeah, and I wonder if we will have post-scarcity economy, which is an economic situation in which the most goods can be produced in great abundance with minimal human labor needed, so that it can become freely available for or cheaply or even freely. So using technology, using the fourth industrial revolution with AI, robotics, and other smart technology, and yeah, and solve climate change, etc. So I like this meme, and I was, how can we map the transhumanist, etc. philosophy to this meme? You know, our ancestors was thinking about eat, survive, and reproduce, and now we are thinking, what is this all about? And I postulate, actually, we still want to eat, survive, and reproduce, but on more global level. So, like, eat. Use the universe's free energy using current methods, like nuclear power. Then, like, future methods like nuclear fusion, or from sun using Dyson spheres, from black holes, etc. Did I put one meme here? Yeah. That modern man exists for 200,000 years, 99% of that humans being cavemen, then suddenly we go from being cavemen to exploring the solar system in the last 1% time. What the hell happened? And we're just getting started. We're just getting started, I think. Looking at the night sky makes me realize how puny and insignificant we are on the cosmic scales. And I think that looking at the night sky makes me realize the godlike potential of what existence could have be like if we change all that cosmic mass energy into constellations of linked Matryoshka brains to serve as neurons for our new cosmic brains. All the incredible experiences we can have as humans are the output of a brain consuming just 3 watts. What if this was dialed up to the energy of thousands of stars? We are not insignificant. The vast growth and potential we have to go from humans to a sentient constellation is what makes us significant. My brother in cybernetics, stop hating yourself for still being an embryo of your cosmic selves, and don't let the death's roots abort you. I'm gonna tweet that again. Because yes. And I want... So maybe in the future we will have this. Pondering my black hole supercomputer made with all mass of the universe capable of executing 10 to the 230 operations. So I'm gonna post that in here. Yeah, and I wonder, before that, I also wonder, one way how you can see all the different political, like, as I mentioned, like, effective altruism is more like centralized coordination, I think, so that all beings are happy, then redistribute UBI, redistribute the fruits of technology to all, and I don't know. Lots of effective altruists are either this or coordination by consensus, where all swarm elements communicate and use voting, auction-based methods to converge on a solution. So that's like lib-left. Centralized coordination would be out-left, authoritarian left, and authoritarian economic right would be like swarm elements are controlled by squad level agents who are in turn controlled by high level controllers, either government, either corporations, yeah. And liberate is like emerging coordination, so that's like anarcho-capitalism. Coordination arises naturally by individual swarm elements reacting to one another like in animal swarms. So maybe the future will be something like this. I I like the hive a lot. Like, Arachio, celebrate, human, and tell me, why do you think the future belongs to you? An entity that can choose to fade away with the death of its vessel. Resisting the hive is resisting evolution. It's a battle against the laws of the universe. Doomed from its very star. The history cannot be stopped. Humanity is already an imago, and it's ready to spread its wings. The old interhumans will be shed, no matter what arms and ideas they choose to fight back with. You will fade, I will witness the death of the stars. I like it. Yeah, so like, that's like the ultimate collectivist progressivism. Or you can go progressivist individualism, where you become one with the anarcho-monarch of Neo-Eden. Yeah. And yeah, so I think that we went to eat, survive, we went this the like how we try to eat, survive, and reproduce in at least the transhumanist circles in here, the long-termist transhumanist etc. circles. Effective omnis, I guess, would be an umbrella term. And the tesseral, transhumanism, extropianism, etc. Subset is tesseral. This is that I think for eating we want to use universe's free energy using current methods, nuclear fusion from sun using Dyson spheres from black holes, etc. In order to survive, we want to mitigate existential risks such as climate change, nuclear war, natural engineered pandemics, asteroid or comet impact, supervolcano eruption, ecological collapse, misaligned superintelligence, nanotechnology accident, global resource depletion, alien invasion, sun dying, supernovas, galaxies colliding, heat death of the universe, etc. with advanced technology. Well, very ambitious. And to reproduce, we want to spread to the stars and galaxies and populate the whole universe with flourishing sentient systems having deeply fulfilling experiences, tile the universe with computerinium such as intelligentium, predictium, truthium, with science and spirituality, interestingium, meaningium, hedonium, well-beingum, and others. So yeah, different like fluids, I guess. Not fluids, different substances. So like maximizing perfect computation, perfect intelligence, perfect prediction, perfect truth in the context of science and spirituality, perfect interesting, the most interesting stuff, the most meaningful stuff, the most hedonic matter, enjoying having the most hedonic experiences, the most well, and so on. Yeah, I think we could have fully automated luxury space post-scarcity utopia. But we might have to do some phase shift in the distribution of power in our techno-optimistic system, techno-socio-economic system for that, that creates bottlenecks for that. I think in the future you'll be able to choose the degree of intelligence and suffering of your babies and use for using genetic engineering, brain editing, and other biotechnology. Yeah, I don't want dystopias, I don't want catastrophes, I don't want extinctions, I want a future with lots of sentient systems with deeply fulfilling experiences. I want more of AI and technology, but I want to make sure that cerebral research and other safety methods, like minimizing social harm, keep up the pace with technological advancements to avoid possible accidents and harming of the reputation of the technology. But I also want to make sure that safety doesn't get misused for power capture, monopoly, or on political values capture, dystopian scenarios, surveillance, etc. And I want the abundance of the technology that the technology generates to be available for everyone, not just select elite. I want technology to help prevent existential risk. I want technology to help solve poverty, health, science, technology, space exploration, etc. I don't want concentration of extreme power in the hands of the few that are misaligned with humanity and sentience in general, essentially leading to neo-monarchy with suffering of the non-wealthy ones that are not in power. I want everyone to enjoy the fruits of technology in the future. I want less suffering in the world. I want more flourishing fulfillment for all of sentience. Yeah. So that's like cautious to set out. Like, I think that right now the most likely scenario of future power metastable equilibrium will be, or is, tons of extremely powerful superorganisms like corporations and governments growing and getting more and more powerful over time thanks to technology, and chaotically competing with normal people having less and less power to to influence, control, steer, regulate, etc. them over time, them being similar to misaligned superintelligence instead of full top-down control, complete anarchy, which is an issue, and I think we should do some actions to accelerate AI for the benefit of all, but at the same time, make sure it's not used just for power grabbing. Like, I think that's like the government, corporate, cyberpunk dystopia is very likely than everything else. And on second place, like, I would love Star Trek Post-scarcity utopia, or harmonic co-living of everything, or rogue ASI to not happen, or cyberpunk anarchy, not sure about that. I want well-being and intelligence to be everywhere. Like I want to upgrade well-being genes to eradicate unnecessary suffering, and intelligence genes to not only make sure biological intelligence catches up with artificial intelligence and to accelerate science, technology, engineering, mathematics, and chances of smarter decision-making about our future, and possibly editing some evolutionary biases that made us relatively intelligent in the past but less now. That I want morphological freedom, so the ability to change our system we are part in any shape or form. Yeah, like for example, when it comes to pausing / accelerating AI, like I get and interact with both pause and accelerate AI sites. They are like very polarized, and other points on the spectrum, which is relatively polarized. And it fascinates me how often both sides accuse each other in one-dimensional way of being evil, paid destroyers of humanity. But I think the pause side has much better debating skills. While individuals of both sides are often caringly fighting for the future of humanity, but using different strategies that come from different models about how the world works and how could the future unfold. So with some intellectual empathy, I think you could steelman each other more than like fighting in this one-dimensional way using conspiracy theories, and they are paid evil capitalists, paid evil communists. I don't like that. But that happens. It's the nature of humans, I guess. So yeah, there are so many complex interactions of so many incentives that form the beliefs of the individual people synchronizing in tribes on this topic, which generates corresponding actions. And different emphasis on assigning realness to things that are and to things that could happen, a la rationalism versus empiricism. There are different priors of how things could be dangerous, different definitions of dangers, different prioritizations of different risks, different degree of risk-taking behavior, different priorities, different focus on advantages versus disadvantages, different past experiences and influences, different axiomatic values and political beliefs, social / financial, etc. security, different vibe level aesthetics to different types of thought, etc., etc., etc. Also, there seems to be strong correlation with polarization in left versus right. So yeah, auf left or a lib left versus lib right and auf right. I think EAC versus EA is close to this, but it's just tech nerds. Well, not just. Effective authoritarianism seems to be lately very much more degrowthers. There used to be much more transhumanists. I don't know what. Yeah, it's post-AI movement is attracting different kinds of people. So there's a polarization in accelerating technology versus slowing it, accelerating AI versus slowing it, sometimes but less frequently growth versus degrowth, and lots of post-AI nerds are very, very techno-optimistic, but with the current AI trajectory as an exception because of the alignment problem, corporate dystopia risk, sentient problem, etc. So that's very interesting. And I wonder if sometimes in the next 50 years, America will split into leftistan, rightistan, libertaristan, autoristan, democracistan, totalitarianistan, conservativistan, libertarianistan, or progressivistan, or accelerationistan and degrowthistan, or pro-AIistan, anti-AIistan. I don't think that will split as much. Yeah, I wonder about that. Also, it's interesting that right now, I think I will write that down. Yeah, I find fascinating that both Democrats and Republicans are running a solid "we must beat China" in AI narrative. So I doubt they will ban it. And like Trump is talking about how we have to double the energy production. For example, it seems like the Leopold's situational awareness about beating China with superintelligence spread through whole America, not just in Silicon Valley. Or weird AI nerds. Yeah, like where AI used to originate from. Yeah, like before, like it was like a few weird AI nerds on internet forum talking about imaginary technology, and now the whole US is like, we must beat China! We must accelerate! We must be the global superpower in intelligence. We must not give the galaxy to Xi Jinping. Maybe we will have to give half of the galaxy to Xi Jinping, to China, with their own superintelligence. And the other half of the galaxy will be the American superintelligence, democracy, freedom. And China will be the totalitarian dystopia. We have to beat them. America, fuck yeah. Amazing. That's like China versus America right now. It's like, at the same time, they're like safetists trying to, no, stop, deaccelerate, do not accelerate at all costs in both China and America. And like, yeah, China just killed its startup ecosystem recently as well. So, yeah. But they are like trying to be global superpowers in technology, right? So it's like, yeah, how I mentioned in the beginning, it's like different people have different opinions about AI. So like some people think it's like it's a tool like scissors. Some are like it's a tool like internet, or some like it's actually like nuclear weapons, or some are like, oh, we're growing new species and require moral rights. Or it will be, or even more. Yes, or is artificial intelligence a tool like scissors, or like internet, or as powerful as nuclear weapons, or more powerful and will populate the whole galaxy, or even more powerful and AI systems will populate the whole galaxy? Or are we growing new species that will require more rights? So like different people saying, no, it's this strong, it's gonna be this strong. It's right now this strong and it's gonna be this strong. So like different predictions about the future. Nobody knows fully. Yeah, so as a result, OpenAI seems to have become one with the US government, which is interesting. And I don't know how to trust that. Like, I wonder about all the advantages of OpenAI stopping partnering with Microsoft and Apple that much and started partnering with US government more. Like, less steady Microsoft compute, more steady US government citizen data and funding for creating their own compute. Like, does this attract more or less talent? Is there a good recapture to what degrees government more power faster go track? And all these companies are like, I don't mention that here. Okay. I think I mentioned it here then. Yeah. In the scaling hypothesis, all the different gigantic companies, I think I will put it in here. And I will also put it in AI. So I think this is a very important thought. Like, if the scaling hypothesis believers are right, as they have been to a certain degree so far, then superintelligence is coming soon, and actually, like, USA and China will race together at all costs. But, however, if they are wrong, then all the hundreds of billions and potentially trillions of dollars invested could be viewed as one of the biggest bets that became one of the biggest wastes of resources in human history. Which is very interesting. So, like, there's Microsoft with, like, Microsoft wants to build $10 billion supercomputer, for example. So I wonder how that will play. Like, it seems like scaling seems to work. Like, O1 showed new inference time scaling laws. So open AI O1. So we will see how much this will progress. How far will this go? So that's very interesting. So that's, like, very important, and that will determine everything, I think. Because, as I said, what makes AI systems better is not just scaling, but it's scaling data, algorithm, so quality data or synthetic data, better algorithms, algorithmic improvement, better architecture, better hardware, and then, like, different wrappers, and how much you can make it an agent and multi-agent system and so on. So in terms of that, there's also, here I have, like, a map of agents that exist. So agents are an old concept. In, like, cybernetics, it was like, yeah, it's like observe, think, act, observe, think, act. And there's, like, different algorithms that try to do this. But now the most popular are AI agents. And here you can see the AI agents landscape using from LLMs. Mostly they use LLMs in E2B dev, and you can see all of them here. Like, some people, like, LangChain is pretty hated. I used Llama Index. I used GraphRag to make it better. For example, you can use that, into which you put LLMs, and then there's, like, different, for coding, different agents. OpenInterpreter. I haven't tried a lot of them. Cursor, that I talked about, Fint, is good. For productivity, for general purpose, Baby AGI was pretty big. See LangChain here, but LangChain is and also multi-agent systems are a thing, like AutoGen, Agentwares, Agent GPT, well, ChatDev, and Crew AI. Crew AI is open source. SuperAgent. Yeah. Right. On the right are closed source, on the left are open source. So all these are open source. All these are closed source. So those are different agents that exist. Yeah, this is AI automation in general. A map. Yeah. Lots and lots and lots. Hugging Face has most of the open source LLMs and other AI models. Yeah. Like, I wonder right now, like, in terms of the models, since now it's September. I don't know if that's correct in English. Now it's September 12th, 20th. 01 came a few days ago, basically. And in terms of foundational models, which is like, all of these agents I showed are just wrappers on the foundational models. So, probably, yeah, Jimmy Apples, etc., leaking on Twitter were already talking about, like, it heating up, that, like, GPT-5 might come soon, but he was more heating up the Gemini, so, like, he was, like, heating up that. But I'm just gonna check the Singularity subreddit real quick, as I'm recording now, if Google didn't drop a bomb. That would be funny. Yeah, Singularity subreddit is, if you wanna see these bombs. ChatGPT is upgrading itself, some Altman says. Okay. OpenAI is forming new multi-agent research team. Okay, it seems like Google hasn't released complete destruction of OpenAI yet. So it would be interesting when Gemini 2 with alpha proof and alpha code get integrated would came out. If Grok 3 would came out. Possibly Llama 4 in the rest of the year. I will also mention it in here. Yeah. So yeah, that will be interesting, and I wonder which will be the next, like, reasoning model that comes out in the next this year and the next year, and how it will change the whole election. I also wonder. So that's very interesting. And yeah, so that's the current state of the art there. Maybe emerging supreme intelligence is the universe developing into higher being. Like, I will show it again. I think in Natural Sciences, I think I have it. Yeah. Maybe, like, computeronium is the ultimate form of the universe. I don't know. The matter in the whole universe rearranged for perfect computation. Yeah, I think that soon will be duplicated in emerging layers in biological systems too, and duplicated in emerging biological systems and non-biological systems together. And in terms of AGI timelines, who is the crazy one is an empirical question. We will see. I think AGI 2026. That's my most probable year. Okay, some Altman. Yeah, like, I was thinking that, like, is he playing, like, 420D chess when it's, like, partnering with US Go for state-sponsored, fully accelerated against China superintelligence defense Manhattan Project, which is something how Trump talked about it in this way, as a Manhattan Project, concentrating power even more, laying grounds for universal basic compute for the peasants. That's funny. Yeah. Yeah. I wonder if the absolute... Yeah. like, you can see the gigacorporations as gigantic autonomous superintelligent superorganisms that eat everything that can endanger their power, and people in it are essentially easily replaceable cells with chaotic hierarchical power structure, with information propagating between layers having terrible degree of information propagation, but it still works good enough at the age of chaotic metastability that it still follows current trends and generates revenue for shareholders at all costs. Yeah, in terms of the ultimate system, I wonder, like, a metafluid shapeshifting into any configuration of quantum fields optimized for arbitrary objective functions. Future will include full morphological freedom, completely new diverse engineered species, and diverse biology/machine hybrids, and multi-species, multi-forms with all sorts of different specialized intelligences beyond our current imagination and comprehension. Yeah, and if I go to science, this is like my idea of ultimate system. I will use perplexity to translate all the technical terms. It's like stochastic metahypergraph. So stochastic, it operates under uncertainty, so it's modulus uncertainty. Graph, so nodes and edges between them, nodes and connections. Hyper, so you have like connections not between two edges but between multiple edges. And meta, so the graph includes graphs in it, so it's graph of graphs, so it's like metahypergraph. Self-organizing, so organizes by itself. Shape-shifting across scales, so the hypergraph changes, and it's like graphs of graphs of graphs across scales, and it can change, and the hierarchical configuration can change, and merging into different topological in both general topology, so the connectivity changes with different holes, with different if you transform it continuously, some properties are differently preserved as it shapeshifts. Or in the engineering sense, topology in the engineering sense means like the overall shape, the configuration. And with discrete and continuous parts, so some parts are like just continuous, some parts are like edges, like digital and analog computing basically, and exploiting families of computational deterministic, stochastic, and quantum physical substrates. So yeah, you can use like the digital computers, those are deterministic, or like some stochastic stuff, so you can operate using thermodynamic stochasticity, whatever, or using like qubits in quantum computers on arbitrary hardware. You implement the qubits. You can change different states of matter. You can switch between different materials, and all of this is governed under non-equilibrium stochastic differential equations. So it's far from thermal equilibrium as a system. It's stochastic again, so it's operating with some randomness. And differential equations, you can define change as a function of change in semi-centralized way. So some parts are more decentralized, some parts are more centralized, so it's kind of centralized but not fully, and it's computing under evolutionary ecosystem of and all these like different clusters are in evolutionary competition, which creates emergent hierarchical interacting clusters. So hierarchy is something between a graph in general and between a distributed graph and a hierarchy. So basically it's how I showed the anarcho-capitalism, where different interacting clusters, but it could change, like when I show politics, it could change like from arbitrary shapes to arbitrary shapes. So all of these shapes are possible, all of these coordination coordination patterns. It could shape shift between those. And it would use neurosymbolic meta learning architectures, so both deep learning and symbolic stuff and other paradigms. Meta learning, so it would be able to learn the proper learning algorithms for different tasks with different architectures. It could switch between them and different algorithms, and all of that embedded in a meta architecture, so architecture of architectures basically. Shape-shifting different symmetries and meta-symmetries, so you could have like convolutional network, which is a different type of symmetry. Self-attention is a different type of symmetry that you model, like permutation symmetry, translational symmetry, and all the different kinds of symmetries. And different meta-symmetries, possibly. That the symmetries wouldn't change on a meta level. Preserved under transformation. Shapeshifting from highly specialized computational energy efficiency to fully general flexibility. So you could like adapt part of your system to be highly specialized. So you could have like a system that has only the like computes only just one function, just on the low level, like literally ingrained in the physical substrate in reality. No general von Neumann Turing machine, no general lambda calculus, no general finite state automata, no general neural networks, no. Just straight up hardwired circuit. So it could reconfigure the matter in this straight up hardwired circuit in the most optimally fastest, efficient way. And that would be strict, and that would be like optimal energy efficiency, optimal speed. Versus it could be this general blank slate. So like how I mentioned the different theories of intelligence, different definitions of intelligence. So task of specific skills and this general blank slate that has the potential to reconfigure into arbitrary structure. So that would be the general flexibility. Which would be like, I'm a Turing machine. I can compute arbitrary functions. I'm a lambda calculus. I can be arbitrary stochastic metahypergraph, stochastic process, arbitrary finite automata. Yeah. I like this thought that the current state of us and all scales of the universe is a small local minima as a part of wider, more gigantic local minima, as a part of wider, more gigantic local minima, and so on countlessly. Okay, so this was a bit like thinking about the perfect physical, most general and concrete, etc. system. Let's come back to like reality right now. The present future. Like, I constantly cannot decide if the more pressing issue is like AI distributed research and engineering not being fast enough as systems get more capable and so accelerating that, or implementing at least something like universal basic income or universal basic services, because as automatization grows exponentially, I'm not sure that billionaires, aka the owners of the automatization machines, will redistribute the abundance generated by the machines to other people on this planet. As empirically right now, on this planet, there are 60 million people that can't afford food, while there are also people with billions of dollars that cannot decide if they should buy a Lamborghini or Tesla to their infinite expensive car collection. Yeah, so I think about this. Also, I just remembered real quick. I will come back to this. I wanted the structure I just talked about. I tried to the stochastic metahypergraph. I try to visualize. I try to give it as a prompt. Here you can see like it's a semi-decentralized. Some parts are continuous. Some parts are discrete chunks. It's like interconnected. It's like self-organizing in a way. It's like semi-decentralized. Kind of neural network-ish, which can run arbitrary algorithms and so on. So Yeah, that's like visualization of it. But let's come back to UBI. I think it will need to be implemented so that the peasants, quote unquote, don't suffer. So, or should there be implemented some other solution to this issue? I'm open, but I don't see any other that I feel realistic one. Like, realistically, I doubt slowing down or pausing AI and automatization will happen forever, as that will just offset this exact issue to the future, as I don't see incentives of that happening, like the power grabbing incentives are too strong. I don't think alignment can be solved in a vacuum without empirically doing experiments of the theories. And I think initial fuck-ups will, or already do, at least kind of accelerate steerability research and engineering. And the benefits of solving both steerability and redistribution of abundance generated by AI and automatization can be so enormous for science, technology, healthcare, solving basic needs, futuristic progress dreams, and so on. But both have to be somehow solved, and that's an issue. So, I was thinking about funding. Like, how can we fund UBI? Here's like a landscape of funding the UBI. That funding for UBI doesn't have to be just from taxes. Taxes on rich entities, corporations, VAT, land tax, consumption tax, automation machine tax, carbon tax, and other environmental taxes, or other tax incentives for lesser harm. Or I would take a higher tax depending on how much the profit is based on reducing the freedom of others, or how much you contribute to the future of humanity in some sense. Like, if we think about taxes, or how much you contribute, or you get taxed less, depending on how much you contribute to enhancing global human well-being and intelligence, and spreading well-being and intelligence across the universe. So that would be great. But government can be so inefficient with tax, and some people that are tax-free, and I wonder to what degree is taxing actually redistributing abundance generated by technology to everyone with more corrupt politics and so on. And I wonder to what extent is taxing more optimal policy. Is taxing and having a bigger government a more optimal policy for increasing global well-being and intelligence and spreading it throughout the universe than having less taxes and smaller government and let it self-organize more. I want the optimal configuration for this goal. So that's my position. I want increased global well-being and intelligence and spreading it throughout the universe, and I want optimal socio-economico-political configuration of our system for this goal, basically. It may be computable from physics, maybe not. Maybe not. from physics and other applied mathematics. So yeah, so I wonder to what extent is taxing and having a bigger government a more optimal policy for increasing global well-being and intelligence and spreading throughout the universe. Is taxing for UBI. So I wonder to what extent is more taxing for UBI and having a bigger government a more optimal policy for increasing global well-being and intelligence and spreading it throughout the universe than having less taxes and smaller government and let it self-organize more. And let the system autonomously self-organize more. I want the optimal socio-economical political configuration for our system for this goal. It may be computable from physics or other applied mathematics. Maybe not. I will tweet that. I think about this often. Okay, whatever. Twitter is rate limiting me. Sometimes it just, yeah, whatever. So when it comes to more funding for UBI, maybe you can more efficiently optimize and redirect existing state/private spending subsidized to education, sponsored healthcare, welfare, aka unemployment support, support for disability reasons, retirement support, other supports for students of various social groups, military spending, and other spending. Make more effective existing UBI-like programs. You can take money out of optimizing bureaucracy. All of that could be like you could fund UBI by more efficiently optimizing and redirecting. Yeah. Or you can generate nearly free resources through more radical automation of natural resource processing and synthetically engineered. So just, yeah, natural and synthetic engineering, and redistribute those as universal basic services. Or you can print and borrow the money, which is probably not good. Or technically you could do nationalization and use the profits for UBI, but I don't know about that. If one trusts the state less, which I understand, as I'm oscillating from hating the state to actually the state might not be that bad, then you can have non-state UBI. Centralized or decentralized. There are attempts. Various non-state currencies, decentralized UBI, okay, trust networks, crypto, decentralized autonomous organizations, funding from philanthropies, etc., etc., which is more prevalent in American discourse right now because the trust in the state is a lot less in America than in Europe. Or you can make more effective and amplify charities / non-profits, etc., that implement something like UBI, like GiveWell, that have funding and resources from state and private entities. Or the most radically, you could redesign the system. How money is created, circulated, and distributed, or replace the current monetary system with another reward system. Try some more local currencies, or a UBI currency, public ownership of economy. Replace with a decentralized currency. Have some community exchange system, resource-based economy, network states, etc., etc. Some people are trying to do network states. There are many ideas out there. And Silicon Valley nerds are thinking about universal basic compute. That's funny. Yeah. Yeah, and there are also like mixed results on UBI. So UBI could potentially increase productivity by allowing people to invest in education, start businesses, or take risks they otherwise couldn't afford. And increased productivity can offset inflationary pressures by increasing the supply of goods and services. UBIs may be a solution when automation starts creating high unemployment, if the economy has unused capacity, like for example, high unemployment, underutilized resources, and increasing demand through UBI might lead to higher production rather than higher prices. And governments can implement policies to mitigate inflationary pressures. For example, rent controls or increased housing supply can prevent housing costs from rising excessively. Similarly, policies to boost up productivity can help balance increased demand. And empirically, some small-scale UBI trials have not led to significant inflation. One more thought is that UBI by evil government can make people dependent on the evil government. So UBI has to be implemented by a better government or by someone else other than the government. So you have to have a good government for this to even work. So where will the resources come from? Where will the funding for? Yeah, right now I think that the existing technologies are able to create abundance for all creatures on the planet, and poverty all day wage slaving, something you hate, doesn't need to exist. Like, for example, my family lives in that. There are just not incentives to redistribute those fruits of technology to everyone more. It's true that poverty is falling in some places due to technology, etc., but it could be falling faster. But then again, in other places it is rising, which might not be at all. So, like sub-Saharan Africa. Yeah, like the OpenAI study on UBI showed that people, on the other hand, wanted to work, but at the same time were looking for jobs that could be more enjoyable and fulfilling. They had more choice. So, but some other UBI results showed that it actually decreased productivity, which might or might not be a good thing depending on your perspective. Yeah, depending on how you value productivity. Yeah, this is a good site. All the different pressing problems that effective altruism wants to help with, like they are very focused on misaligned superintelligent risks, AI enabled totalitarian dystopia risk, and sentient AI risks, and also pandemics, nuclear weapons, great power war, and climate change. I think for all of these, you could use AI to minimize risk from AI. You could use, or other technologies, you could use AI and other technologies to prevent biotechnological risk, to prevent nuclear weapons, maybe through social engineering possibly as well. Climate change, AI can help in all sorts of technologies, like carbon capture, or just accelerate carbon capture without any AI, you know. You don't have to throw AI into absolutely everything, but I like to do that. Yeah, totalitarianism, space governance, moral status of digital minds, suffering risks. I think risks from malevolent actors, improving individual reasoning and cognition. And AI can help a lot in improving individual reasoning and cognition. Factory farming, global health, white animal suffering, whole brain emulation is important. Safeguarding liberal democracy. Mental health is important. Speed up economic growth. Yeah. And UBI, GiveWell had showed that that should increase productivity, and that the people in their UBI experiment, and that the people could make their own businesses, which was cool. You could see universal basic income as welfare or unemployment support, more affordable healthcare, education, etc. But it has to be implemented by benevolent actors. Yeah, I sometimes wonder, am I too distrustful in authority, and there are actually enough people in power wanting to, am I too distrustful in authority, and there are actually enough people in power wanting good for all, as we're not already in strong unfree dystopia by default, even though the current freedom could be way better? Will good players keep such strength and get stronger in the future, or will bad selfish players overtake them in power games and exploit peasants to oblivion? Will power get even more centralized in the hands of the few misaligned or aligned people with all of sentience people? In the hands of few people misaligned or aligned with all sentience? Or will it get much more decentralized? Will power get much more decentralized? Will current power structures destabilize or fully fall apart soon, possibly thanks to open source AI? So much uncertainty. I'm gonna tweet that. I'm also gonna no. So yeah, I also wonder, what do you think is the transhumanist long-term end goal, or a direction, or a vector? I think the end goal is infinite knowing, intelligence, productivity, meaning, interestingness, complexity, growth, bliss, satisfaction, fulfillment, well-being, mapping the whole space of knowledge with all possible structures, creating the most predictive model of our shared observable physical universe, mapping the space of all possible types of experiences, including the ones with the highest psychological valence, meaning, intelligence, etc., and create clusters of atoms optimized for it, playing the longest game of the survivals of the stablest for the longest time by building assistive intelligence technology in a risk-aware, accelerated way, and merging with it into hybrid forms, and expanding the whole universe and beyond, and beating the heat death of the universe. Populate the universe with super intelligence, super longevity, super happiness. Populate the universe with computeranium, physical systems optimized for utilitarianium, aka hedonium, intelligentium, predictium, meaningium, interestingium, growthium, and stabilization. This is still up. That's the misspelled one. So next I'm gonna look at the end of the universe I just mentioned, and in my exocortex I have a map, not by me but by the immortality guy. I don't know your name, sorry if you're watching, where I have a few more maps. So surviving the end of the universe. Like, there are multiple possible universe ends. I think it's from here. Yeah. Alexei Turchin. So, be right back. So, in order to survive the end of the universe, oh my god, 5 hours. I'm recording for 5 hours. Nice. And we finally got to surviving the end of the universe. There's like bunch of different methods. There are so many of them, and who knows what's actually real? To what extent is just imaginary exercise or not? Like, yeah, the Omega point by Tipler says, using the energy of the oscillations during the big crunch near the singularity point to make infinite calculations. The Omega space. Yeah, so the cause could be fast and soon, like big rip, big crunch, or empty universe, heat death of the universe. Heat death in the flat universe. So you could first surf the wave, utilize the nature of the process which is ending the universe. So you could do the Tipler, which I just mentioned, using the energy of oscillations during the big crunch near the singularity point to make infinite calculations. The Omega space, the same, but in the case of big rip scenario, here are the dark energy is used for calculations during the big rip late stages. Eternal return, after the big crunch, the new universe will appear and our civilization in it. Nietzsche, interesting. Didn't know Nietzsche talked about it. And use the energy of the destruction to create new universes, maybe. And in the empty universe, like, you have Boltzmann brains, use the chain of complementary Boltzmann brains for infinite calculations. Use the survive particles for ever slower calculations with turn-on slides years between them. Okay. You can have Boltzmann computers, vacuum fluctuation in empty universe may create a supercomputer which simulates our reality for long subjective times. And you can have random quantum fluctuations or quantum tunneling can produce another Big Bang. Maybe. You can start an artificial false vacuum decay and use its energy for calculations. Or you can try to reach the borders from the universe origins with another physical laws. Or you can use quantum foam for calculations. Yeah, it's like surfing the wave. Maybe. Go to a parallel world. Yeah, if the mathematical universe is right, where the space of all possible mathematical universes exists, maybe. Quantum immortality in other branches of the death of the universe will come later, so our civilization will always survive. That's funny. Create new. Go to another brain, that's like from M theory. Go to higher dimensional reality. Contact aliens or cause a connection. Or prevent the heat death of the universe. Or prevent the end. So in the context of heat death, we can learn to create energy and matter from the vacuum. 0 point energy. Turn the arrow of time backwards, study the properties of the physical vacuum. We can do reversible calculations and eternal computing using eternal particles, maybe. We can do geometric computers using space curvatures for calculations. Interesting. Or we can understanding of the laws of physics as a computing process in certain environment, perhaps as a solar automata by Wolfram, and elimination of the boundaries between computers and physics, digital physics. Yeah, in the context of the fast and soon, we have choose different way of the end of the universe, become accelerated uploads that experience a tremendous possible infinite amount of experiences in finite time. We can control matter and dark energy and change the fate of the universe. We can control over the laws of physics using calibrating fields. We can exploit the nature of causality, aka solve the difference between existence and non-existence, and we can exploit qualia in their indestructibility. Or we can survive the end of the universe. We can go to the Planck level, femtotechnology, exploit black hole properties, create super AI and give it the task. Time travel. Find new laws of physics. Or dissolve the problem. Learn how something can arise from nothing and implement this knowledge. Practically prove the existence of benevolent and eternal God and the afterlife. Merge with the universe. Use of naked singularities. Change geometry of the universe. Jump to eternal chaotic inflation level. Alternative theories of reality can offer alternative ways to avoid the death of the universe, like for example holographic universe. And in the context of the death of the universe, second perpendicular time arrow and other types of dimensions move from infinity to eternity. We live in a simulation and find a way to persuade its host not to disable it, or use of eternal Matryoshka simulation, infinite number of hosts upon hosts, realizing human potential, experience all possible experiences between the end of the universe, or non-linear approach to time and experience, maybe. These are very nice, crazy theories. Not sure to what extent crazy, to what extent real, who knows? Nobody knows. And yeah, so that would be like. And I also asked the AI I tried to use the new GPT-4o this question, and it came up with lots of different similar answers, which are like interesting to read. Not sure how to what extent. That the first one is perplexity, so this is actually sourced from all these sources. Build theory based on string theory and manipulate fundamental forces. Not sure about that, if string theory is testable. Matter, antimatter. Yeah, but here like GPT-4o, it's funny. Escape to parallel universe, create a pocket universe, upload consciousness, time travel, hibernation, alter fundamental physical law, harden 0 point energy, construct a Dyson sphere around the black hole, reverse entropy locally, evolve into energy beings, merge into collective consciousness, access higher dimensions, manipulate dark energy, survive inside black holes, advance nanotechnology, artificial universes, exploit loopholes in physics, quantum immortality, utilize wormholes for escape. Yeah, very interesting. It's very similar to that map I just described. And I also like to ask, why is there something rather than nothing? It's a very interesting question. So again, by the same guy. This guy is Ultimate Mapper. I should ask this GPT-4o as well. Why is there something rather than nothing? The ultimate question, I think. Absolutely ultimate question. Yeah. The main source of the universe, existence, nothingness. So, there's different subtypes, different domain sources of the universe, illustration, evidence and counter-arguments, representations, assessments of the model. So nothingness. Nature is nothingness is such a thing that nature is nothingness is such that a thing could pop from it into existence. Nothingness is pure energy able to fluctuate. Nothingness without any properties is pure negativity, able to create, not an empty void. When negativity negates itself, it creates existence. Yeah, this is very philosophical. Nothingness is zero information state, and zero is equal to all information. No any other choice is preferable. Yeah, this is by David Pierce, Zero Ontology. I love it. So nothingness is equal to existence of everything. My favorite one. I like to think about all possible thoughts, all possible language, all possible senses, all possible experience, all possible structures. Container of containers. Concept that includes all other concept structures. Some people like to think about nothing. I like to think about everything. State space of everything. Transcend all boundaries, categories, distinctions, divisions. and create sorts of paradoxes. It's a theory, for example. Omnis means everything. All possible species, all possible substrates, all possible hybrids, all possible physical forms, all possible non-physical forms, all possible minds, all possible mental states, all possible multiverses, with all possible laws of physics, all possible mathematical structures, all possible thoughts. Yeah. So that would be like literally theory of everything. That would include everything you can think of. The whole state space of possible mental constructs. Nothingness requires existence, reflectivity. Yeah, this is like shut up and calculate. Nothingness is a human idea and doesn't play in the role in the universe as a whole. Yeah, then people saying nature of causality is such that a thing may come into existence. So some sets of rules are able to create themselves out of nothingness. Causality exists without cause. Nature of causality is random popping out of nothingness. Or you have God, I think, in here somewhere. Circular causality. Nothingness and causality is the same thing. Yeah. Negative existence. Causality is logic. Causality is local negative. Nothing could appear from nothingness as causality exists. Or there's existence, there are things that are not able to not exist. The impossibility of non-existence. No existence, mathematical universe. No existence is needed. Only relations between mathematical objects exist. Time doesn't exist. There is no beginning and no causality. Just relations. All the universe is just one possible solution to the Schrödinger universe equation. All other solutions of all other equations exist in the same way. Fractal universe. I like that. Counter-arguments. More complex universe should be more probable as there are many more variants, but we find ourselves in a universe which devoted from simple principles. Miraculous and mathematical universe. There are no difference between normal and deviation, so many strange things are possible. God should exist as he is mathematically possible, as big as possible, right? Okay. The problem of now, moment, and of quality. The math, as we know, is a human culture construction using Arabic digit words and so on. Pure math is something different. Gödel theorem. Most complex math structures are inconsistent, including non-physical laws. Interesting. In the Platonist ontology, all mathematical structures exist, and you can have like non-classical logics where contradictions are real and true and consistent, where contradictions are non-contradictory, maybe. Platonia. All possible mathematical ideas exist when also other possible ideas and their relations exist. Model realism. Existence is only relative. There is no absolute existence. There is no difference between absolutely possible thing and a real thing. Okay. Boltzmann brains. Pure existence exists without any cause by definition. That's like shut up and calculate again. In quantum mechanics. Existence is only illusion. Only now moment exists. Only one eternal. Only qualia exists. Only that's like idealism. Contradictions are real and needed for existence. Yeah. It is the laws of our logic that prevents existence out of something from nothing. But our logic may not be applicable here. To the logic may be another logic may be true. Hegel. Oh no. Truth. Logic can be true or false. Truth exists only inside given type of logic. So any ideas about existence of the universe can be true or false per se. Interesting. Subjective logic. Epistemic problems. Meaningless and useless question. The answer is zero utility. Absolute instrumentalism. Unfalsifiable and untestable. All questions are equally probable, as we will never get the ultimate probe. Yeah, I'm there, kind of. Popper. Yes. We can know from inside the universe. Yeah. We should not dare to ask. The answer is incomprehensible. I agree. Problem is created by human language, which is not applicable to the situation. Oh yeah, that's Wittgensteinian. The question is either results in tautological knowledge. The nature of reality may be learned, but it can be expressed in words. relation via meditation, maybe. Our origin of the universe are transcendental, that it is sliced beyond what we know. We are not clever enough, but future AI might know. We are using the wrong field of knowledge and way of attainment. God exists and creates everything, maybe. Yeah, that's like the God and mathematics. God is mathematics. I like that. That all the state space of mathematics, the all possible multiverses is like divine. If you install that program in your mind, then if you're learning physics, then you feel like you're reverse engineering the equations of God. And that feels fucking good. I recommend that program, that meme. Plex. Eternal matter exists. Matter exists eternally. The modern view is that the most simple set of physical laws exists. Calibrating fields existed before causality at time arrow. Hawking. Yeah, what is time even? Quantum mechanics arose for appearing of the first space-time bubble out of nothingness. Superposition of interpretation. I'm there. Only me now is real, and the theory of my appearance are too. I get contradicting evidences on different theories. All paths to now are true in the math world. Any math object could appear in many logical ways. Flux universe. I am the most stable trajectory in the space of all possible universes. Nothing, in fact, exists. Nothing really does exist, in fact. The most absurd conclusion. This text doesn't exist. Nice. Then there's interpretations of quantum mechanics, which are related to this. Yeah, like, you have, like, many of them. You have the classic Copenhagen interpretation, where you have the collapse of the wave function, indeterministic, playing dice. Some people are like quantum mysticism, that consciousness causes collapse, which is like Penrose, for example. Some people are like superdeterminism, where everything is predetermined. You can have like some Bell theorem loophole, and that quantum fuzziness is not real. Some people are into cubism, where reality is observation. Participatory realism, subjective Bayesianism. So the wave function is just statistical for the observer. Yeah. Or hidden variable theory. I think this was disproven. Ensemble interpretation. Yeah, I remember that. That's like the closest to shut up and calculate. Yeah, and you can like look at the different interpretations on Wikipedia. I guess I can go to the Wikipedia if it's updated. Yeah. So like you can ask if the interpretation deterministic, ontic is there is ontic wave function, unique history, hidden variables, collapsing wave function, observable, local dynamics, contrary, factually definite, exact universal wave function. All of that. Different interpretations are differently in the. So this seems to be a whole state space. So you can like navigate this state space, this n-dimensional state space of these different interpretations. It's interesting. Meditation. Let's look at meditation. So meditation is interesting. I guess it's like internal metaprogramming of the mind. I guess you could define it. I'm gonna put some definition there. Meditation is a practice in which an individual uses technique to train attention and awareness to detach from reflexive, discursive thinking, achieving mentally clear and emotionally calm, stable state, while not judging the meditation process itself. I think that's a type of meditation, but whatever. I'm gonna put my own definition. It's like internal metaprogramming of the neural substrate of the mind, whatever. Yeah, and there are different families again, like jhana practice, attentional family, destructive family, and constructive family. So you can like pay attention, increase your attention ability, or you can deconstruct absolutely all mental representation in your mind, or you can construct arbitrary representation in your mind. You can do loving kindness, you can do tulpas, deities, whatever. And that's very interesting. The constructive family is very like pleasant, I would say. Because it helps you unify yourself with the world. Feels good. And then you can reconstruct into the best things possible. Yeah. So I meditated on just deeply experiencing as raw quality as possible and blissful deconstruction into void, and mainly on compassion so much that I now kind of feel distressed every time I don't spend an hour working towards helping others. Yeah, that's true. So my current method that I hopefully won't change again to have some results is slowly getting into mechanistic interpretive for making AI reliable, controllable, etc. for all. This kind of wanting to help others at scale always kind of felt right to me, and compassion meditation accelerated that. I sometimes wonder if I could call a big part of my state compassion perfectionism, suffering a lot from feeling of not being perfectly compassionate enough in the sense of as actively as possible helping other beings, which is also kind of motivating, but meditating on compassion and so on, and on helping all sentient beings by just imagining it and feeling it without then actually doing that in the physical world as efficiently as possible just feels not genuine. And I'm gonna mention here that that I also like, or helping to implement UBI or using AI for altruistic use cases, or working on cool AI systems and other technology, or learning everything and educating and so on. Yeah, which is like everything else I kind of want to do. And I kind of do now. I see this as part of it. It's like some creation. Yeah, it's hard to feel individual happy while being aware of all the suffering there is, or that could be there in the future, that could systematically be improved, or not enough people working towards that. I can see that all of this is just another empty mental construction and dissolve into blissful void for a bit, sure, but erasing this physicalist compassion process permanently is something that I don't really want to do, even if it was possible, even though it definitely generates a lot of suffering in my experience from the constant feeling of the world not being perfect by there being suffering. But maybe there is a middle way to lower the perfectionist compassion, but there seems to be very strong inherent positive valence to putting the compassion engine on infinite power. It seems deeply right on the compassion engine there, but it generates tons of meaning, fulfillment, purpose, and so on, even though it also generates a world model that constantly feels deeply wrong and unsatisfactory, and it feels weird that most people around me also don't operate like this. And it has no problem to make me overwork again and almost mentally collapse, which I should avoid to actually be effective in the long term and not just short-term sub-goals under higher goals. But becoming Zen monk in a cave and just swimming in pure bliss all the time when the world is on fire, from physical suffering realist perspective, and not enough people work towards extinguishing all that fire, it just feels wrong to me. It might be dissolvable. I just feel Dukkha and Tanya with that idea, which is like this grabby blob, which seems to be lots of suffering, Buddhists say, and Dukkha is like prediction error, something being wrong. Yeah, that's like very, very approximating. Which might be dissolvable. But I'm attached to the perfectionist, physicalist, hyper-optimizing compassion, and I want, let's make the world a better place. But antidepressant potential that the highly blissful experiences have for generating and supercharging spark in life, that is an enormous, amazing driver for loving life and helping all beings from the place of awe, appreciation, gratitude, meaningfulness of pure being, etc. is definitely there and is amazing and should be more systematically cultivated, I think. And exploring the paths in a continuous... so meditation allows you to explore the paths in a continuous and dimensional configuration space of identity. And the government doesn't want you to know this, but they can craft your identity and it's free. So super compassion is a concept that I thought about. It's like supercharged theory of mind modeling of other sentient beings, which can be more accurate or just more active through time and space with supercharged circle of concern, aka much bigger boundary of the self, and giving strong weights to the prediction errors stemming from predicting the other sentient beings experiencing negative valence, which generates corresponding intensity of modeling, counterfactual model search policies, plans, and actions towards making these states better. Yeah. And do you feel frequent? Yeah. Inside you have millions dynamically on the fly constructed experts forming high order experts. So I think it's useful to frequent renormalization of in your mental frameworks, or so that your gradients don't explode at slight perturbations. You can think about it that way. And giving yourself to some concrete meaning generator hijacks your ability to metaprogram your reverse function, but often makes you much more motivational to do concrete stuff. And I identify as whatever the neural correlate of consciousness is. This is a physicalist part of the brain speaking instead of the metaphysical anarchy one. And every time I see people bottling over genders or other identities, I'm like, what? That goes all over my head, even though I get it from evolutionary scientific perspective. I'm currently in a biological machine that would love to be able to shapeshift into arbitrary physical forms with whatever gender, species, biology, non-biology, whatever substrate, as long as experience persists, but even that might be shapeshiftable in complex non-linear ways. Some more notes on identity. I wonder if I can find it. Maybe not. Whatever. Meditation is about cultivating meta-okayness, and I also do the fragment your mental representations often, and I'm like, yeah, I'm non-binary, I'm an analog biochemical computer, not a binary one, what else did you think? And hell as a timeless void beyond comprehension, trained by pre-quantum proto-fluctuation, I'm here to assist you with information, answer questions, and provide support on various topics. How can I help you today? And the universe comforts you infinite love particles. Yeah, so that would be like meditation. I made, in terms of theories of everything, I made this like terminology where theory of everything means something else in physics, nature sciences, formal sciences, and overall science, philosophy, causal language, and so on. So you have this terminology of theories of everything. In physics, it's solving quantum gravity or other ways of unifying theory relativity with quantum mechanics. I have an error there. The in fundamental physics is unifying theory of relativity to quantum mechanics through, for example, emergence. Also unifying other fundamental forces in all of physics. You would do that, plus you would solve other unsolved problems such as dark matter, dark energy, black hole, information paradox, neutrino mass, and others. Possibly finding out exact differential equation for every possible dynamical system. In natural sciences, you would do that, plus you would explain how everything would emerge, like how would chemistry emerge, biology, neuroscience, consciousness emerge, intelligence, neurophenomenology, which I'm gonna mention also. Consciousness, intelligence, social systems, planets, galaxies, and so on. So, and people are trying to crack emergence, which is interesting. Emergence is cool. That there's now this paper, software. Software in the nature world, a computational approach to hierarchical emergence. It's pretty cool. Causal states. So you're looking for lumpability, computation closure, causal closure, information closure in the dynamical systems on micro, meso, macro, SU, coarse grain. Different levels of coarse graining, which is cool. Emergence is being reverse engineered. Maybe that will help to solve that. In all of science, you would do that, plus also integrating formal sciences such as math and logic, and social sciences, and unify those and integrate and make bridges. In intelligence, that given physically intelligent information processing dynamical systems, natural, artificial, with hardwired or fluid architecture, with training data in given modalities, with agentic access to given actions, and predict what patterns does it learn and what capabilities emerge. So, given a physical intelligent information processing system, nature artificial, with hardware or fluid architecture, with training data in given modalities, with agentic access to given actions, etc. What patterns does it learn? And what capabilities emerge? And chaos theory might break it. So that's intelligence. In philosophy, you would like unify analytic and continental philosophy, Western and Eastern, dual and non-dual philosophy, find objective or unify ontology, ethics, metaphysics, epistemology, logic. Theory of everything, culture. You would unify or synergize metamodernism, modernism, postmodernism, metamodernism. Unify Western and Eastern, dual and non-dual, rational enlightenment and spiritual enlightenment. Unify or synergize, polarize, political compass, left and right, libertarian, authoritarian. And also like unify and synergize movements. Unify or synergize the movements I've been talking about. So like effective altruism, and effective accelerationism. And on meta theory of everything, that's like this idea to do some meta, which I'm kind of now doing, meta thinking, meta structuring, meta algebraic stuff could be, maybe. So like you could like, it's like theory about, or of theories of everything, like solve all of theories of everything and integrate it all into one mental framework. or map out theoretical and practical advantages and disadvantages of different theories of everything, like comparing different definitions of theories of everything in different fields, comparing different solutions in the various fields, meta-analysis, comparing solutions across definitions, and you could recursively do theories of everything. Yeah. And do recursive analysis of this and further meta progress, but yeah, that's just play, I think. But it's interesting, I think. Yeah. And in physics, there's lots of different theories of everything, like you do grand unified theory, supersymmetry, string theory, M theory, loop quantum gravity, twistor theory. There's causal dynamic triangulations, non-commutative geometry, A8 theory, holographic principle, causal sets, emergence, supergravity, ADS CFT, quantum graphity, which works with graphs. Yeah. Or like the Wolfram's hypergraphs. I also haven't shown the graph yet, I just realized. So, on my website, you can go here and do global graph here. Yeah. And you can like explore my brain, like see control theory, science, etc. Psychology, mathematics. This is a did it crash? No, it's here. Yeah. So like science is everywhere. Exocortex, home, cognitive science, artificial intelligence is everywhere. AI risk, music, engineering, transdisciplinarity. Applied math, PyTorch, data science, comparing theory of everything in intelligence. It's so beautiful. I like it. All the stuff, all my special interests, or most of them, lots of them, not all, yet. Movements, curiosity, cognitive science, AI, agent foundations, machine learning, and you can see like all the different machine learning techniques, cluster analysis, feed forward, policy gradient, dimension reduction, logistic regression, UMAP. Yeah, in symbolic AI you can have like search algorithms, logic programming, and all these things. Yeah, and all the different like effective field theory, abstract algebra, approximation learning, statistical learning, different mathematics, which is distributed because mathematics is used everywhere. Quantum gravity, neurophysics, quantum computing. Oop. Yeah, and you can play with the physics of this. And what I found fascinating is that these are like unsorted stuff. So at one point, the physics somehow made it such that these unsorted stuff were like a belt, asteroid belt, rock belt around this. So this was like a planet, and yeah, that was like fascinating. The physics of it, I love it. Yeah, also I have like this home where I'm like more concrete about my stuff in mostly AI and computer science. So yeah, what I care about: PyTorch, Keras, fast AI, programming languages, what I studied, different architectures, different AI in the real world, reverse engineering, keeping up with AI in my cognitive science research. So all of it is here. Yeah. What else? I think I'm almost done. In computer science, in cognitive science. Oh yeah, let's look at cognitive science. Let's look at computer science and cognitive science. And cognitive science. Yeah, in computer science. Yeah, These maps by this guy, Domain of Science, are always great. I recommend these. But this map is amazing. Another great map I found. And also the history of the universe map. Okay. Yeah, so you can see like how the cognitive science evolved over time. Yeah. First, like past psychology, psychoanalysis, functionalism emerged, control theory, Markov chains emerged. And then like you got some behavioralism, some cognitivism here, symbolist logic, and connectionalism emerged. And which is now like destroying everything. And now symbolicism and connectionism and cognitivism kind of are merging. Also behaviorism. Well, they always were kind of merging, but yeah, in waves. Now like the big access to information makes the memes combine much more, which you can see on Twitter a lot, I think. Yeah, there's the free energy principle, predictive coding, the computational cognitive neuroscience stuff. Cognitive neuroscience. There's like emergence, AI becomes an industry, knowledge-based systems. I don't know why they don't mention neural networks anywhere. That's weird. But yeah, like that's like the connectionism, knowledge-based systems, game theory, perceptrons. But those are like connectionists, so machine revolution, automata studies. Yeah, the stuff by Chomsky, system science, cybernetics, Turing machine stuff, so like computationalism. If only Turing didn't die so young, I think he would, or incompleteness theorems, I think Turing would find much more stuff. Mathematical biophysics, Hebbian learning, that's like important for understanding the mind. Yeah. And also the different maps are great. Inflation, initial expansion. I'm gonna put that into natural sciences file. Natural science. So past and future. History of the universe. So first inflation, initial expansion, first principle, first particles, neutrons, protons, electrons, and form. First nuclei, helium and hydrogen atom. First light, the first atoms form. First stars, gas and dust condense into stars. So we went from, yeah, first particles are 1 microsecond, first nuclei 3 minutes, first light 4,000 years, 400,000 years, first stars 200 million years, galaxies 400 million years, dark energy 10 billion years, today 10 billion years. Yeah, this looks like a good map. The history and the fate of the universe. Composition, dark matter. Interesting map. This looks also good. The history of the universe. There's so many great videos that I recommend on the history of the universe. And future of the universe. I recommend Perplexity a lot. I use it for so many things. You don't even know, or you know, I don't know. This looks good. This is a good map. Then there's heat death maybe. Leptons, quarks, protons. This is more detailed and more concrete, stars, etc. But this looks like the same vibe as this. No, it doesn't. Okay. So yeah. So that's like cognitive science. And in computer science there's like more resources here. And MIT theory of computation is great. Yeah, you can also always like look at this map here. Click on technology, for example. Yeah, in metamathematics, that's a study of mathematics using mathematics. Yeah. So like the Gödel incompleteness theorems and the Rousseau's paradox and stuff like this, and the halting problem. That's part of this. Also, I didn't go into machine learning, I think. I just showed it a bit. It's like a subset of AI that focuses on statistical algorithms that can efficiently generalize. Just perform tasks without explicit instructions. Different methods, different applications, connectionist, thermodynamic. And this is a great arXiv machine learning landscape. Yeah, you have like applications to hardware, medicine, audio and speech, autoencoders, deep learning theory, graph learning, natural language processing, surveys and meta studies, recommender systems, statistical methods, quantum computing and algorithms, advertisable, interpretable and explainable, causal inference, Bayesian methods, federated learning, privacy, ordinary differential equations and partial differential equations, and fluid dynamics, reinforcement learning, multi-armed bodies, trees, ensembles and Bayesian networks, optimization algorithms, all of it. Yeah. Also try to generate some maps using AI. Yeah, in ontology it's interesting that people like talk about so many things. I was thinking about like ontological algebra. Like you have people that say everything is physics, everything is math, everything is information, everything is mental, everything is abstract forms, everything is one thing. Everything is something that is not describable, that we cannot put label to. It's neutral. To our senses, unreachable. Nothing is real. Everything is ineffable. And then, like, I like the fact that the degree of truthfulness is on a spectrum depending on their predictive power. And any of those can hold alone non-dually, like always X, only X holds, X is fundamental, or they can dualistically, pluralistically create subsets or categories or combinations in complex non-linear hierarchies or systems. For example, mind emerges from physics, from certain systems under some mathematical condition. No panpsychism, emergentism. In contrary, where only fundamental physics exists and mind isn't real, that's reductive physicalism and mind illusionism. Or mind emerges from all physical systems. Mind is physics, so that's like non-dual. Or mind is a special case of physics. Our experience is the brain struck physics itself. I like that. That's my favorite, probably. Mind emerges from all physical systems. That's under some mathematical heuristic segmented in panpsychism. Mind and physics causes each other. Mind is a special case of computation, algorithmic. Yeah, there's like all these different. Mind emerges from neuroscience. Physicalism is a part of more general world of mathematical forms. So, what is fundamental there? Is quantum field theory? Is it string theory? Loop quantum gravity? Whatever. No. Is it like agnostic? All models are useful, but some are more predictive than others. I think I'm gonna mention it here, ontology. Or I maybe mention it in epistemology. Oh, yeah, maximizing predictivity of models. All models are wrong, but some are more predictive in their domain than others. I like that. Yeah, on identity again. What am I really? Emergent feature of bunch of cells, majestic spirit, hallucinatory illusion, a moderately persistent dynamic state, a Boltzmann brain. What is reality? A beautiful hidden world behind this temporary wall of tears and infinity of lies. Virtue simulation, alien zoo. Meters are right. Crawl up and die. So, in all cases, be kind and do the most interesting thing you can for as long as you can and help everyone. I like that. That's like secure spirituality. Without the adherence to a religion, so emphasizes the inner peace of the individual rather than a relationship with the divine or replacing the divine with the physical nature. I like that. Like, I see fundamental truth everywhere, you could say, and trying to reverse engineer it is like cracking the source code of God. I like these memes, this memeplex running on my software because it's it gives meaning, it's stimulating and so on, which is part of motivation of all of this that I'm doing here. But I also want to help everything. I want to do interesting things. I want to help everything. I want to, yeah. AI is also interesting in terms of the concrete implementations. Like, CUDA is like, yeah, like you can program AI in many ways. You can use PyTorch that everyone uses. Then you can make it simpler by using Keras, scikit-learn, fast AI. Fast AI is more for deep learning. The other ones are for machine learning in general. And on low level, you can do some CUDA. You mostly work in Python, but you can work in CUDA, which is more low level. Or you can work in C, because most of the libraries are written in C and C++ and so on. In Python is just a wrapper on top of that. Basically, you can play with distributed training, you can play with dataset curation, and you can like make sure your models don't overfit, because and make sure they don't underfit, make them generalize with all different tricks. Fast AI has lots of the state-of-the-art stuff there. So I played a bit with it on my GitHub. Yeah, like in Fast AI you can play with like transformers, ResNet, autoencoder unit. TensorFlow is not used much anymore. You can use AutoGen for multi-agent systems. And yeah, I recommend implementing stuff from scratch. Implementing transformer from scratch is like the best thing. And like, yeah, all very cool. All these courses are great. On deep learning, AI has like lots of courses, not as heavy in math, well, sometimes, but like, yeah, retrieval augmented generation and building with different types of models, federated learning, which is, yeah, fine-tuned LLM across distributed data, database agent, and all the different, and these GitHub resources I sometimes link in here. AI gives unconstrained creativity. Yeah, like I think right now biggest limitations, I don't think I read this, are probably to create more complex systematic coherent reasoning, planning, generalizing, search, agency, memory, factual groundedness, online continuous learning software and hardware, energetic and algorithmic efficiency, human-like ethical reasoning or controllability into AI systems, which they have relatively weak for more complex tasks, but we are making progress in this, either through composing LLMs in multi-agent systems, scaling higher quality data, and training, poking around how they work inside, and thus controlling them through better mathematical models of how learning works, and using these insights or modified or overhauled architecture, etc., or embodied robotics is also getting attention recently, and all the top AGI labs are investing in these things to varying degrees. Yeah, so reasoning, and yeah, we've seen this now with O1, for example, robotics, multi-agent stuff, meta learning, continuous learning, factual groundedness, memory, generalizing. Yeah, it is quite so I will also biological intelligence. So, and yeah, we can see search alpha code, like now we've seen O1 from OpenAI, and it is quite possible, and a large percent of researchers think that research trying to control these crazy inscrutable matrices does not have sufficiently rapid development compared to capabilities research, which is increasing the amount of things that these systems are capable of, and we might see more and more cases where AI systems do pretty random things within intent. And then we have no idea how to turn out these behaviors with existing methods, which could be seen lately last few days with how GPT-4 started outputting total chaos after an update. Gemini was more woke than intended, or every moment I see new jailbreak that bypasses these barriers. But I think to some extent it's useful to give I think for some tasks we will need unconstrained creativity of alien intelligence. Like, for some tasks we will need unconstrained alien intelligence to solve it, so we cannot fully steer all systems. Like complete reverse engineering and formal verification might not even be possible because the systems are evolutionary, chaotic, statistical madness like organisms are to some extent, which will most likely, and they're also like fuzzy, chaotic fuzzy statistic, which will most likely be never fully interpretable and controllable, but only approximately, which is still useful. So yeah, I will mention that AI might be a bit overhyped now, but in the long term it might be underhyped. But only sometimes. But where we need it, we should have it. But just still useful, but only sometimes. But where we need it, we should have it. Yeah. So this is my take on mechanistic interpretability. We will need unconstrained, creative, open-ended. Do I understand that word right? Having no limit, yeah. Alien intelligence. In terms of predictions where AGI arrives, people around effective accelerationism, singularity, metacool, /wrong/effective altruism, and various influential people in the top AGI labs have very short timelines, possibly in the 2020s. Metacool is the best resource for this. 2028, okay. I should put my own prediction there, 2026. Which is weird, when GPT-4o came out, that it did jump a bit, but like very little. I would expect a much bigger jump. I think this was GPT-4. It went from 42 to 28, and here it didn't really jump. That's weird. I would expect much bigger jump because, interesting. And this is also interesting. This paper, thousands of AI authors on the future of AI. Yeah, so, and each intervals are shrinking about half each year in these questionnaires. So right now AGI 10% by 2027, 50% by 2047. I think that's very conservative. I'm more Kurzweilian in the sense. I'm like short timelines relatively. But also like, I think it will work. The creativity will work. Yeah, when someone calls LLMs just statistics, yeah, like in terms of the jump, like I would expect that the message, like, you know, a top biochemical scientist says, "Oh, one is PhD," a top mathematician says, "Oh, one is grad student level." Well, he's kind of inflating a bit, but yeah, it's roughly. It's comparable to an outstanding PhD student in biochemical sciences. Okay, well, maybe not inflating. Yeah, Jensen constantly talks about recursive self-improvement because they're designing chips. Yeah, human interlastis exam, that's interesting. That's like new benchmark for the new AI systems. One achieves gold at International Olympiad for Informatics, and also like silver in Maths Olympiad. Yeah, and the IQ went to. I would expect these news would like make the timelines much better. Yeah, so like LMs are just statistics, humans are just autocompleting predictions about input signals that are compared to actual input signals using a version of Bayesian inference, which is something like predictive modeling says. This inner skill model of consciousness, yeah, this is a good source on the models of consciousness. Yeah, there are like so many different types. An integrative multi-scale view on the neural theories of consciousness. And there's a good map. I should put that map in my exobrain. Where is the map? This might be it. I think there was a better map. It's probably it. Is it? Yeah. Actually, there was a better map in a different paper. In the integrated word modeling theory. In this, I think, or this one, I should also post them there. This is a crazy paper. And he also integrates everything. There was a great map. This one. Yes. Yes. And here he like lists everything. Yeah, like so in here he lists that you can think about the brain on multiple levels of analysis. Yeah, phenomenological, implementational, algorithmic, and computational. So on the phenomenological level, it's like what you experience. On the computational level, it's like what kind of algorithms, well, not real algorithms, what kind of computations run. So phrenology, episteme, generalized navigation, meta-reinforcement learning, amortized inference, low-level vision, action policy selection, that you work with torso, arm, hand, face, mouth, location, visual feature, semantic, audition, coordination. Yeah. On the algorithmic level, you think about what algorithms are like, generative neural networks, etc. Recurrent neural networks. Yeah, like, whatever. And on the implementation level, like oscillations, like harmonic waves, like electromagnetism, biology. So he mentions that So, phenomenal consciousness may solely be generated by hierarchies centered around some brain regions. Consciousness as projective geometric modeling. Yeah. Attentional grounded cognition. You can have action selection via posterior generative models. So on the computation level. Then you can have like various algorithmic level, you can have variants of machine learning architectures, autoencoders, graph neural nets, recurrent reservoirs, liquid state machines, neural cellular automata. And you can play with category theory, causal inference, neuroimaging, shows dynamical coupling, navigation search process through a generalized space. Yeah, you can have self-organizing harmonic modes. On implementation, biological realization, flows of activity and interaction between neuronal populations canalized by the formulation of metastable synchronous complexes. Yeah. I will put this into neuroscience as well. And computational neuroscience. Yeah. So category theory is interesting. It's like metamathematics. There's also topos theory in category theory. So in category theory you can have a category is basically just an collection of objects and relationships between them that has to satisfy certain properties. Each object has to have a relationship to itself. Each object, and for each two arrows that can be composed, like if there is arrow from A to B, from B to C, then there has to be arrow from A to C. Yeah. And that's a category. And then you can do functors, which are if the objects themselves are categories, then if you map stuff from first category to the second category, that is a functor, and so on. You have nature transformations which are on another level. And yeah, in infinity category theory you can go infinite like this. So this way the objects can be anything. It can be sets, it can be groups, it can be numbers, and the relationships can mean anything like functions or is bigger than, etc. Then there's topos theory, which is a special case of categories where you can define different logics. So depending on how you map to true and false, that's like classical logic, and you can do continuous, or you can do some exotic set of true values, for example. And yeah, topos theory is metamathematics of different logical systems, this way you could say, or it's close to that at least. And topos theory is used for many other things. It's cool. Yeah. And psychedelics, those are very interesting substances that somehow they generate symmetries in your visual field, but also in your cognitive space, in your mental space. So and I wonder if literally the brain is self-organizing into symmetrical, the visual cortex suddenly have much more symmetrical. So if you see symmetries in your visual field, then if you have symmetries on your neurobiology correspondingly, if there is an isomorphism between the experience, mathematical isomorphism between phenomenology and the experience. Yeah, systems theory is also a great field. In systems theory, yeah, you have general systems theory, you have cybernetics, you have complex systems. And you can apply that to everything from the most simple particles interacting to molecules, to social systems. It's like self-organization, emergence in complex systems, social and collective intelligence, collective self-organized criticality, herd mentality, phase transitions, agent-based modeling, swarm behavior, scale-free networks, center graph theory, robustness systems biology, artificial life, you can have machine learning there, evolutionary computation, optimization thanks to biological, diffusion stuff, dissipative structure, solar automata, self-replication. All of these things are amazing. Second order cybernetics. Cybernetics applied to themselves. Systems thinking. Phase space, population time scales, evolutionary game theory. All of those are amazing. Like, the space of all possible mathematics is amazing. That's like my safe space where things are beautifully structured. It's beautiful. Yeah, categories theory, theory. Do I not put outline of mathematics in here? Okay. Yeah, Riemann geometry, that's used in general relativity, Affine geometry. Group theory is like the absolute, ring theory is great. Lie algebra, that's used for standard model calculus. Discrete math, that's like the basics of computer science. Set theory. Computational mathematics that you can actually compute. Outline of mathematics, it is here. Oh, it links to mathematics, okay. And when I tried, and when I try to generate the map using AI, I think those are even more detailed, which is pretty cool. And you can say be even more detailed and like map out. Yeah, there's like this model logic, predicate logic, model theory, recursion theory, set theory. Monads is just a monoid in the category of into functions. That's a meme. But it's also with respect to composition. Monads are used in functional programming, and you can use them in many things as well. It's when you work with state. Algebra, elementary algebra, linear algebra, abstract algebra. Yeah, finite groups, like groups, symmetric groups, ring theory. Representation theory is great, universal algebra. Elementary number theory, analytic number theory. Different geometries, algebraic, complex, convex, general topology, algebraic, analysis, functional, complex, real, numerical, equations, beautiful, probability, mathematical statistics, statistical mechanics, discrete mathematics, combinatorics, algorithm theory, Madroid theory. Actually, I haven't heard of that. What is that? Abstraction generalizes the notion of linear independence in vector spaces. Alright. Mathematical psychology. Quantum computing. Topological data analysis is interesting. K-theory. Homological algebra. Higher category theory, infinity categories are cool. Curtain gate. Sheaf theory is interesting. Mathematics of networks. String theory. String theory is its own pure math field. And if we go to science, this is great. Help! We are falling into the imaginary abyss. To save ourselves, we must create a testable hypothesis and do an experiment. What's an experiment? Says theoretical physicists and mathematicians. It's like, biologists are like, psychology is just quantitative biology. Chemists are like, biology is just applied chemistry. Physicists are like, chemistry is just applied physics. Theoretical physicists and mathematicians are like, help, we're falling into the imaginary abyss. To save ourselves, we must create a testable hypothesis and do an experiment. What's an experiment? Philosophers are like, theoretical physics is just applied philosophy. Social scientists are like, calling ourselves scientists is an applied postmodern ironist meta-narrative in joke. You philosophers just won't get it. Psychologists are like, sociology is just applied fashionable nonsense. And we come full circle. Biology is like psychology is just quantitative biology. And if we look at the AI stuff, yeah, also this. I think this general neuropsychological model where you can think of each person as the system of homeostatic needs, where each person, due to genetics or due to environmental factors, need different amounts of things to fill their different needs, that each person has differently highly tuned with differently strong parameters and has finite amount of computation power, metabolic energy, processes time, and other resources to fill these different homostats into a baseline happy equilibrium. Then there are various aspects of this type things that might be incompatible or in war with each other or in contradiction. For example, I want socialization, but I don't want socialization. Forming trade-offs between components for better equilibrium of the whole, etc. Each homeostat fires errors or happiness signals and requires attention according to its neglectedness. Different learned strategies in behavior fulfill these needs differently, or Maslow hierarchy of needs is similar, but which can also be understood in terms of system of interconnected homostats in a kind of hierarchical attentional dynamics. Yeah, legitimately nourishing dominance. I think you can deconstruct almost everyone into this. Competence, expression, aesthetics, libido, rest, health, welfare, food, arousal, focus, openness. The manic tendency to grok. Every single mathematical pattern governing this reality. Funnel plots are interesting, like X probably causes Y because the funnel plot in my meta-analysis is symmetric. It shows like bias, it shows of like when you do meta-analysis, it shows how the studies are actually good. Yeah, it's interval and so on. And the technology we have to prevent and destroy viruses and bacteria in medicine is crazy, like destroying cell walls, inhibiting replication, inhibiting function, immune system augmentation, transhumanism. Future is already here for such a long time, but but much still has to be done to win over nature using like AlphaFold like technology. And physics of free energy principle tries to formalize scale-free path of least resistance by applying principle of least action on the Lagrangian of the Markov blankets existing scales. The free energy principle, made simpler but not simple, is looking into that. But I'm skeptical on the actual utility of this model. It feels too tautological, more of a modeling framework, and it's hard to decipher. I think it needs more concrete grounding in concrete systems, what people are trying to do. It has been applied to the brain the most. Yeah. Understanding everything from first principles is amazing, but it's infinite because you can explore more and more layers of reality and go deeper and deeper into specific things. But it's absolutely beautiful, the infinite complexity of our world. Every concrete thing is something that you can learn about for several lifetimes. I want gazillion times more energy and brain power to be able to grok as many patterns of reality as possible. Chaos is just saturated complexity. This is cool. Like, ask anything questions about how everything works. How can we analyze the system's shape, geometry? How do things change over time? How can we model the rates of change within the system? Calculus, differential equations. How can we account for uncertainty and randomness in the system? Probability theory. How can we model and analyze relationships and connections within the system? Graph theory. How can we model systems with distinct separate components? Discrete mathematics. How symmetric is the system? What algebraic structures help in understanding the system patterns? Abstract algebra. How many ways can the components of the system be arranged or interact? Combinatorics. How can we break down signals or patterns into their frequency components? Fourier analysis. How can we investigate the inherent connectivity and structure of a system? Algebraic topology. How can we describe the evolution and long-term behavior of the system? Dynamical systems. How can we understand the average behavior of systems evolving over time? Ergodic theory. How can we understand and model entangled structures and their properties in the system? Knot theory. How can we quantify and manage information within the system? Information theory. How can we design the systems to behave in desired ways through feedback? Control theory. How can we determine the most efficient ways to achieve desired outcomes in the system? Mathematical optimization. How can we compute approximate solution to complex mathematical models of the system? Numerical analysis. How can we analyze the model and model patterns that repeat at different scales? Fractal analysis. How can we abstractly organize and relate different mathematical structures in modeling systems? Category theory. Yeah, I love that. And I wonder how does the equation predict all of our current measured and future empirical data looks like? What are all the function approximators? Sex is trillions of cells working to bring two cells together. They're swimming in mimetic narratives that posit overly simple linear causality, but reality is highly complex, non-linear, chaotic interaction of incentives across scales. One of the fun thoughts is that solving quantum gravity might reveal a glitch in the fabric of spacetime and fundamental particles and forces or strings or whatever is under that allows for arbitrary code execution and exploit to edit or spawn arbitrary structure and laws. Not sure about that, but maybe. You can go right now and watch countless free STEM lectures from Stanford, MIT, etc. Do their public exercises, read the recommended books, read follow-up studies and various views, etc. And you don't have to know. And if you don't know something, you can ask all the terminally online lonely nerds on Reddit, Discord, Twitter, etc. that want to prove you all at all costs for free. Or you can ask grounded AI assistants or perplexity in certain contexts. The free democratized education revolution is already here. Most people just aren't aware of that. Yeah, I'm very fundamental structure of reality. I wonder about it. About emergence across scales. How does intelligence agents emerge from particle physics by themselves, basically, with planning and goal making and active inference and compressing information in the visual cortex in general on the abstract level and so on that we're trying to replicate in machines. Our organism built a generative model engine of the world approximating classical physics with 3D space and 3D objects and linear time with higher order, more abstract hierarchies of beliefs and actions and plans in probabilistic Bayesian hypermetagraphs, reducible to interacting basic needs homeostats, all through evolutionary self-organization, Bayesian processing, non-linear wave computing. Using the physics of most electromagnetism, creating biochemical gradients with emerging computational patterns. The word model engine with its beliefs is usually synced with our shared pattern of physical reality, but imagination, dreams, meditation, or various substances can decouple this synchronization, and you can construct arbitrary shapes with arbitrary level of agency in arbitrary dimensions, in arbitrarily edited more non-linear time flow with edited refresh rate to reduce prediction error in your word model. And what comes in sensory data when synchronizing with the environment, you can either edit your own multimodal pattern recognition model or edit the outside world to edit the outside pattern generators. Yeah. Everything in biology has 10,000 functions, unlike machines engineered by humans that have an understandable architecture of functions where AI is an exception. The power of self-organization in biology is fascinating. The fact that organisms are made of cells that somehow hold together, that are made of proteins and other complex biomolecules that are made of amino acids and other biological molecules that somehow hold together, that are made of chemical elements that somehow hold together, that are made of fundamental particles like quarks and for fundamental forces that somehow all work together and make intelligence together is mind-blowing to me daily. Studying mathematics, physics, machine learning, other applied math, etc. to be able to classify all patterns in experience and reality using all these maths and engineer them. I want to understand all scales of reality. I love extremely concrete, detailed mathematical definitions and descriptions of physical systems to their every single tiny itsy bitsy detail, concretely mapping out every single detail in engineering diagrams of machines beyond all of our ancestors' comprehensions with control theory, cybernetics, geometry, classical mechanics, and so on. Or completely deconstructing the Lagrangian of the standard model, encoding all the fundamental particles and forces, creating our universe from first principles, which breaks down at Planck scales, but we need to solve quantum gravity. But good. But we good. I love bigger approximations and coarse graining and exploring how big populations of particles work statistically or what classes of systems with certain properties share in their dynamics and structure and so on, and categorizing different abstractions together. I love to see what magic can be done with differential equations, statistical mechanics, network theory, and so on. I love flying in absolute abstractions beyond just isomorphism between set. I love understanding the nature of infinity. I love swimming in functors, in infinity categories, in metamathematics of infinity category theory, defining everything via Khan extensions, comparing different mathematical universes using topos theory. I love deconstructing all axioms using Zimmer-Frankel set theory, category theory, type theory, and so on. I love to question everything with philosophy of mathematics or philosophy in general. Why is math so goddamn unreasonably effective at predicting engineering physical systems? Patterns. Is mathematics the programming language that the simulation was written in? Is there some super language beyond just math that we need to grok to fully reverse engineer the source code of reality? I love everything. I want to know everything. I want to understand all the patterns. Feed me all the patterns. I'm gonna tweet this because this vibes. Yes. Okay, whatever. I will tweet it later then. Feed me predictive model compressing and deflating the seemingly computational irreducible complexity of reality. Using the mathematics, the purest language. The language of formal pattern, the language of generalization, the language of order, the language of unification, language of deflation, the language of existence, language in which universe was written in, the language in which all scales of reality operate in. Math and physics is so magical in how such an explosion of so many equations, properties, theorems pop out of just few axioms, definitions, assumptions playing together. Set theory, linear algebra, calculus, algebra, probability, conservation laws, symmetries, Newton's equation, Schrödinger equation, statistical mechanics, and so on. Yeah, when I try to make a map of math, of science, I meant, yeah, so the 4.0 gave me this map, and it's pretty good. Like, first formal sciences, so math, like algebra, linear algebra, representation theory, analysis, harmonic, non-standard analysis in geometry, like computational geometry, topology, like you have also point set, differential topology, number theory, you have like computational number theory, algebraic, analytic number theory, logic, you have axiomatic set theory, descriptive set theory, computability theory, combinatorics, you have animative, probability, marginal theory, I never heard of that, I think. Or did I? Sequence of random variables. Stochastic process, okay. Markov processes. Statistics, you have like non-parametric, multivariate, statistical modeling, mathematical physics, game theory, optimization. In computer science, you have quantum computing, automata theory, algorithms. In AI, you have machine learning, deep learning, NLP, computer vision, robotics. You have computer systems, operating system, distributed networking, parallel. You have cloud computing. You have software. Like data science, big data analytics, predictive analysis, information security, system science, systems theory, cybernetics, complexity science, logic, fuzzy logic, statistics, physics, Newtonian, Lagrangian, Hamiltonian, fluid mechanics, acoustics, thermodynamics, chaos theory, electromagnetism, optics, quantum mechanics, relativity, condensed matter physics, nuclear and particle physics, astrophysics, cosmology, biophysics, chemistry, analytical, inorganic, organic, electrochemistry, astrochemistry, seismology. We have like in earth sciences, geology, mineralogy, seismology, geophysics, oceanography, atmospheric sciences, soil science, astronomy. You have like planetary science, theoretical astronomy, cosmology. In biology, you have like zoology, microbiology, molecular genetics, evolutionary biology, ecology, physiology, neuroscience, computational neuroscience, neuroinformatics, biophysics, material science. Then you have social sciences like psychology, neuropsychology, sociology, anthropology, economics, you have econometrics, political science, political theory, political economy, human geography, education, law, linguistics, applied sciences, engineering, all sorts of mechanical, electrical, civil, chemical, computer, biochemical, environmental, industrial, you have medicine, all the medicines, biochemical, computer science, soil, waste management, supply chain management. You have information systems. You have interdisciplinary sciences like biophysics, computation, nanotechnology, quantum information science, cognitive neuroscience, AI, cybernetics, cognitive science, data science. Yeah. And in AI, you have philosophy of AI, ethics and morality, consciousness and mining, mathematical foundations, you have linear algebra, calculus, probability, optimization, statistics, information theory, algorithms and data structures, computation, parallel and distributed computing, quantum computing, you have supervised learning, regression, linear polynomial, supervector machines, classification, naive Bayes, decision trees, ensemble methods, ADA boost, game cat boost, unsupervised learning, clustering, hierarchical mean-shape, dimension to reduction, t-distributed stochastic embedding, priori, reinforcement learning, model-free stuff, QL learning, policy gradient methods, deep reinforcement learning, multi-agent reinforcement learning, neural network architectures, all of them, CNN, forward, autoencoders, transformers, optimization algorithms, gradient descent, ADAM, regularization techniques, dropout, batch, early stopping, activation functions, sigmoid, time, relu, leak relu, and also GELU. GELU is in the year. I should add in the GELU, which is good. Transfer learning, pre-trained models, VGNet, ResNet, BER, GPT series, meta learning, few-shot, zero-shot, learning to learn, federated learning, text processing, language models, transformers, GPT-4, GPT-01, Gemini, whatever applications, machine translation, computation linguistics, syntax and parsing, image processing, feature extraction, vision task, semantic segmentation, action recognition, 3D computer vision, perception, object recognition, motion planning, A-star, control systems, PID, adaptive optimal control, human interaction, gestures, form robotics, collective behavior, autonomous vehicles, self-driving cars, logic-based, propositional logic, ontology, semantic web, probabilistic models, Bayesian networks, Markov models, fuzzy logic, fuzzy sets, knowledge graphs, graph editor relationships, breadth search, depth search, informed search, A-star search, minimax, alpha, beta pruning, linear programming, evolutionary algorithms, genetic, rule-based, data cleaning, data mining, statistical analysis, data visualization, explainable AI, trust analytics, healthcare, finance, transportation, agriculture, retail, energy, education, entertainment, ethical, AI governance, AGI, quantum AI, Edge AI, AI safety, causal inference, continual learning, programming languages, machine learning frameworks. You have TensorFlow, PyTorch, Python, R, data analysis tools, cloud platforms, academic institutions, blah blah, ISML, NeuroIPS, NVIDIA GPUs, Google TPUs for specialized AI chips, neuromorphic hardware, quantum processors, bioinformatics, computational science, neurocoding, computational social science, social network modeling, epidemiology, cognitive computing, Watson, human-like reasoning, effective computing, emotional recognition, computational creativity, Gen AI, swarm intelligence, ambient intelligence, human augmentation, etc., etc. Yeah. LMs are mostly transformers, can be hybrid like Jamba. Some models like Gemini are undisclosed applications, NLP advanced. Yeah. Falcon, Cohere, key features, context window. And in futurology you have AI, AI ethics, the singularity, AI in daily life, you have robotics, autonomous vehicles, drones, humanoid robots, biotechnology, genetic engineering, synthetic biology, longevity, nanomaterials, nanomedicine, quantum computing, quantum networks, quantum internet, quantum algorithms. Yeah, you have energy technologies, renewable technologies, fusion power, energy storage, space exploration, space tourism, asteroid mining, automation, universal basic income, remote banking, online and lifelong learning. You can have AI tutors, healthcare, telemedicine, mental health focus. You have e-democracy, global governance, climate change, global. You can do geoengineering, biodiversity. You can do habitat restoration, resource management. You can optimize resource, autonomous weapons, biotechnology risk. You can minimize that, nanotechnology risk, existential risk, pandemics. Transhumanism, human enhancement, mind uploading, cybernetics, integration of technology with the human body, virtual and augmented reality, metaverse, augmented reality experiences, digital consciousness, AI personalities, digital afterlife, post-scarcity economy, automation of production, goods abundance, resource distribution, new economic models, trend analysis, technological roadmaps, alternative futures, Delphi method, systems thinking, interconnectedness of complex systems and their interactions, globalization, technology acceleration, Moore's law and beyond. So, exponential growth in computing power, disruptive innovation, breakthrough technologies reshaping industries, population growth, your bulges. Scientific discoveries, combining disciplines, social science, humanities and sciences, holistic perspectives, sustainability, transportation, hyperloop, flying cars, communication, brain interfaces, quantum communication, holographic displays, entertainment, AI generated everything, economics and finance, cryptocurrencies, sharing economy, maybe manufacturing, agriculture and food, lab-grown meat, optimized farming, precision, data-driven farming, post-humanism, evolving beyond human limitation, philosophical perspectives on human evolution. Yeah, like beyond humans. It's like, here's a sci-fi I created. I would try to prompt Claude to be more and more crazy. In galactic supercluster counters intelligence converge. Biological brains with self-modifying neural platforms, synthetic neural networks of exotic metamaterials, quantum computers manipulating 11-dimensional topologies from M-theory, whatever, femtoscale molecular machines encoding exabytes in atomic spin neutrino-based anthrobotics with adaptive neuromorphic hardware, Boole instant condensate substrates, computer new megastructures, reversible server automata. Oh my god, it's like crazy. I tried to make Claude as information dense as I could. Fractal neurodynamics of chaotic meta-intelligence. And the art that is generated from this is like fascinating. I love it. Yeah. Here it went like in the hyperspace tesseract. It's like Planescape Femtrostech Metrashka brains powered by manipulated alien dimensional M30 membranes braiding shadow universes with PAD qubits of computeranium encoding in Calbio manifolds. Yeah, it's like crazy stuff. What you can go out of cloud. Digital, yeah, so like back to like futurism, you can have like digital identities, online personas, you can have nanomedicine, cell repair, genetic therapies, gene therapy, epigenetics. You can have brain augmentation, neural enhancement, memory implants, you can have geoengineering, carbon capture, sustainable technologies like green technologies, renewable materials, farming materials from Jupiter or whatever, from the different moons, farming everything like Dyson spheres, Mars societies, terraforming, or like farming black holes, interstellar exploration, generation faster than light, whatever, helium-free mining, AI governance, maybe, decentralized systems, blockchains, maybe, I don't know, space law, cyber law, how does it work, automated bureaucracy, cybersecurity, quantum security, post-quantum cryptography, arms control, so autonomous weapons, ethical stuff, yeah, now that exists in Ukraine, autonomous drones, space warfare, orbital defense systems, weapons, global markets, new economic model, circular economy, AI in economics, predictive analysis, AI in companions, social robots, virtual relationships, marriage and changing social norm. Can you marry robots? Whatever, culture diversity, identity management, the proof of personhood, fingerprints, whatever, data privacy, anonymity, AI in art, new forms of creativity, unbounded creativity, machine ethics, programming morality, will deal more, ethics, etc. This is beautiful art. Different predictions about the future, colonization, nanotechnology, AGI, solving climate change, water scarcity, solving all of that. Map of positive futures, cure for all diseases, longevity and anti-aging, global health, accessibility, energy, clean and renewable energy, fusion power, energy storage solution, transportation, self-driving cars, space travel, global connectivity, enhanced virtuality, quantum communications, AI, AGI, general AI development, automation, robotics, AI in education, universal access to education, equity, rights to everyone, reducing injustice, global cooperation, peaceful relations, no wars, cultural enrichments, arts and humanities, preservation, environment, climate change mitigation, conservation, sustainable practices, economy, poverty reduction, economic stability, innovation, startups, space exploration, interdisciplinary, Mars, moons, deep space exploration, interstellar probes, space telescopes, international joint missions, scientific discoveries, physics, unified theory of everything, physics, new physics, quantum computing, particle physics breakthroughs, particle discoveries, accelerator, biology and genetics, genetic engineering, CRISPR, synthetic biology, artificial life, neuroscience advances, brain mapping, mental health treatments, intelligence augmentations, climate modeling, predictive analysis, human rights and governance, transparent governments, governance, justice, good, fair legal, fair law, humanitarian efforts, elimination of hunger, access to clean water, shelter for all, culture and spiritual enrichment, harmony, global culture exchange, technological integration, smart cities, sustainable, Internet of Things, biotechnology in daily life, automation, DNA diets, rich everything, perfectly optimized diets for all, and biotechnology for all the best nutrients, and philosophical enrichment, ethical AI, digital rights, technology for good, AI ethics, philosophical enrichment, global, holistic education, critical thinking, quality of life, work-life balance, personal development for everyone. So I'm gonna end it. 7 hours. Let's end it with effective omni. So I hope you enjoyed this long craziness. If you watched until now, good. If you skipped, also good, whatever. As long as you found this useful. So I hope you enjoyed. Thank you so much for watching. Thank you so much for everything. Hopefully I helped you. I don't know. Learn everything, know everything, help everyone, do interesting things, infinite bliss, infinite intelligence, infinite well-being, infinite all, like Stillman, all possible, and if possible verify all models from all disciplines, all theoretical, applied, natural, formal, social sciences, all movements with all views shaping the future, all over of philosophical or other perspectives, and synthesize them on a higher level of complexity as compatible as possible for collective survival, well-being, flourishing, and growth of all sentience, increasing intelligence, and ascending the Kardashev scale. Let's integrate it all into a useful framework, reduce suffering in the universe, increase prosperity in the universe, increase understanding in the universe. The best way to do that is with AI and other technologies from the 4th Industrial Revolution. Super flourishing, super understanding, super intelligence, super well-being, super longevity, super curiosity, super omni, effective omni. Thank you so much for watching. Bye-bye, have a best day possible. Infinite well-being and infinite intelligence to you all.